The boundaries between Earth's oceanic plates are alive with seismic activity,
Banyak berpotensi tsunami.
ready to trigger one of the deadliest natural disasters known to man, a tsunami.
Jesus Christ, look at that.
When monster waves hit coastal populations,
Get in!
their power is unstoppable.
This earthquake and the tsunami is much larger than they had thought could be generated at that subduction zone.
Multiple assaults carry loved ones away,
We're hoping against hope that they're still alive somewhere.
inundating land for more than 3 miles.
Life has gone. The place has been destroyed.
And leaving a catastrophic death toll.
They'll still be finding bodies now, I would imagine. They would never have recovered everybody.
Around the world, humanity exists only moments from catastrophe. Disaster bubbles below the surface of the earth, strikes from the heavens, or engulfs us from the sea. But we are not merely at the mercy of our planet. In our pursuit of industry, global connectivity, and reach for the stars, lives have been lost. Disasters reveal the best and worst of mankind, as one tragedy compounds another. How do these disasters occur? And what lessons can equip us when catastrophe strikes again? December 26th, 2004. Deep below the waves, off the western coast of Sumatra, the seafloor was ripped apart by a massive earthquake, measuring an average moment magnitude of 9.2.
That was one of the 10 largest earthquakes ever recorded, and it was the third largest since 1900.
This earthquake ruptured a huge fault. It was about 1,200 kilometers long, all the way up along the subduction zone in the Sumatra region.
As the fault unzipped directly opposite Aceh province, its capital was rocked by powerful tremors. The panicked residents of Banda Aceh flooded into the streets as their homes crumbled. But the worst was yet to come. Millions of people around the Indian Ocean were about to be overwhelmed by one of the deadliest natural disasters in recorded history. The earthquake violently shoved the seafloor upwards at a speed of 10,000 kilometers an hour.
This is one of the classic tsunami-generating earthquakes. They call it a subduction zone event, where two plates grind against each other, one's pushing the other one down, and then it essentially flips up and bang, that generates a wave.
A very large subduction zone earthquake might displace the water by 4 or 5 meters, which might not sound like all that much, but it's doing it over hundreds, if not 1,000 kilometers area. So it's a major disturbance to the ocean's surface, and that's a lot of energy.
The displaced energy transferred into the surrounding water, triggering a powerful wave.
And that wave, because it's in deep water, doesn't really have anything to slow it down. So it's going very fast. We're talking 800 kilometers an hour.
The tsunami sped toward the Aceh coastline. Those who could fled, but for many, it was too late. The torrents of water and rubble dragged thousands to their deaths and continued to surge inland.
It's not just one wave, it's multiple waves. And they're coming at a coastline with such force. And when they inundate or flood that area, they can travel up riverways, they can travel up other bodies of water.
And in particular, in the case of Banda Aceh, it actually came from two directions. It came from the west and also came around from the north. So there were accounts of people who ran one direction only to find that they were facing the tsunami coming from the other direction.
Comprised primarily of fishing communities, most of the immediate victims in Aceh were women and children.
A lot of the women and children were located close to the coast, so the children may have been in school, and the women may be at home or working in agriculture, and the men may have been out at sea, fishing.
Some of those fishermen may have been completely unaware of the horrors unfolding at home.
Bolak-balik tempat kejadian merapu dan adanya lon balik ke dia ikut yana mayat tersangkut-sangkut.
A large tsunami in the open ocean might only be a couple of meters high and might even go unnoticed by ships at sea. But when it approaches shore, it undergoes a phenomenon called shoaling, where all the energy that's in that deep column of water gets compressed.
So you have what's a small wave in the deep ocean, of about 50 centimeters, and then when it's coming on shore, in the case of 2004, probably about 5 meters high.
Some of the waves that hit the northern tip of Sumatra exceeded 30 meters, flattening the coast. However, the island was just the first in the firing line. The tsunami was speeding toward Thailand, where beach resorts across the south were packed with tourists enjoying an end-of-year vacation.
The tsunami travels about the speed of a jet plane. So if you imagine flying in a jet plane across an ocean basin, that's about the speed a tsunami travels. Although that's enough time for a proper warning system to deliver a warning to communities, it's not that much time.
Unaware of the cataclysmic rupture 500 kilometers away, holiday goers at Patong Beach in Phuket witnessed a strange phenomenon. The sea was receding. As the tsunami approached, water was getting pulled back to feed the wave.
That wave is building up. The one behind is pushing like crazy. This wave is getting bigger and bigger. It's slowing down. That crest is growing. And then suddenly it turns around and starts coming back towards you, and it comes in so fast, you cannot outrun that.
An hour and a half after the earthquake was first registered, the tsunami hit Thailand, where tourists in Phuket bore witness to the wave.
I was fine. I knew I was high up. It was a good, strong building. The waves were rolling. I thought, yeah, it's fine, it's fine. Jesus Christ, look at that.
Jesus Christ.
It wasn't a wave. There was just solid water behind it, and it just kept coming. That wave is a good 15, 20 feet tall. Easy. Nothing was going to stop that wave.
It breaks a long way offshore, so you just have this roiling mass of hell, you know, up to about 5 meters high, zooming towards you at about the speed of a 5,000 meter Olympic runner. So, can you outrun that?
Just hit and there was devastation. Boats getting smashed everywhere, people being washed away, just carnage.
Water rushed into hotels, in some cases inundating the third floor.
Rooms filled up in 30 seconds. One of our friends had to throw the TV through the window to climb out. There's cars gone through shop windows, trucks being blown over.
The destructive power of the tsunami was unstoppable. Each cubic meter of water weighs a ton, and the waves from the Indian Ocean delivered 100,000 tons of water to each 1.5 meters of coastline.
The power is unbelievable. Just back there was a tractor, and it's nothing against the power of the wave.
The event is chaotic because a tsunami destroys everything. It doesn't pick and choose. It doesn't say, oh, I'll leave that house behind, or I'll leave that kid behind.
He was lost for 2 hours. The flood washed him away by himself. And he hung onto a door in the hotel until the water came down and came out 2 hours later.
Of the Thai areas hit, Khao Lak suffered the worst, with 4,000 perishing. But the tsunami would continue, sweeping across the Bay of Bengal. 2 hours after the earthquake, and 1,700 kilometers from the epicenter, Sri Lanka was next. Resorts near the coastal city of Matara were assaulted by waves.
It burst through the door, and we were lucky in other rooms it burst through the whole wall and just washed in, at which stage we just left everything and ran.
When Sri Lanka was hit, a railway train on the coastal line was crowded with passengers. At the village of Peralaya, the first of the gigantic waves arrived. The train stopped as water surged around it.
People felt that the train was going to be a safer place to be than to be on the ground. Not necessarily a very good choice.
නමුත් අර ඊළඟ වතුර පාර ලොකු වතුර පාරක් ඇතුළට ආවා ආපුවම මේකම එකපාරටම මේ කම්පාර්ට්මන්ට් එකේ පිල්ලා ගියා වතුරෙන් කෝච්චි එකපාරටම පොඩ්ඩක් මේ එක මේ මංගුවක් හැරුණා එක ඇන්ගල් එක කියන්නේ 90 degrees ඊට පස්සේ මම අර අතන මේ අල්ලගත්තා මේ අර වීදුරු ළඟ තියෙන පොඩි දැලක් වගේ එකක් මම ඒක අල්ලගෙන උඩ රැඳිලා හිටියා.
It's a bit like people being in a car when the tsunami comes. You know, a car's full of air, a train's full of air. It's easy to pick up and throw around, and that's exactly what it did, essentially. And probably in the region of about 1,500 people were drowned, crushed.
In terms of the death toll, it became the world's single worst train disaster, adding to a confirmed death toll of over 35,000 people. An estimated 90,000 buildings across Sri Lanka were destroyed.
The southeastern part of Sri Lanka and the south part were the worst hit, most definitely. You could see inundation going well over a kilometre inland. A lot of the tourist hotels on that part of the coast, you couldn't see them anymore. It was just a layer of rubble disappearing into the distance.
The seismic shock of the 2004 earthquake rang the Earth like a bell, causing the entire planet to vibrate by as much as a centimeter. It was recorded as a moment magnitude 9.2 event, a scale used by seismologists to compare the size of earthquakes.
Magnitude's a number that's logarithmic, and what that means is every time you step a magnitude unit, you're increasing the motion by about a factor of 10 and the energy by about a factor of 30.
Before the moment magnitude scale was developed in the 70s, we really relied on the amount of shaking that was observed in an earthquake to determine how big that earthquake is. But the moment magnitude scale is important because it relates to actual physical properties of the earthquake. It's proportional to the area of the fault that ruptured in that earthquake, and also the amount that fault moved in the earthquake.
The Sumatra quake was the third most powerful ever recorded. However, a tsunami-triggering event in 1960 released almost 3 times the energy.
The most powerful earthquake ever recorded is a magnitude 9.5. It's called the Valdivia earthquake, which came in sort of southern central Chile.
On the 22nd of May, South America was throttled by a quake lasting over 10 minutes.
Rubble and ruin in the Pacific port of Concepcion in Chile, which has suffered the worst series of earthquakes in all its history.
problem with that event was that it was so big that it was outside anything that had happened before.
Waves up to 25 meters assaulted the Chilean coast.
There's a big debate as to how many people died in 1960 in Chile, anything between about 1,000 and 5,000 people, which is a huge range. Bearing in mind it was not a particularly well-populated coastline, that's a lot of the population, because they simply couldn't get away.
The tsunami waves would continue to propagate across the Pacific. Waves were recorded 10,000 kilometers from the epicenter, as far away as the Philippines.
It killed people in the United States. It killed over 100 people in Japan, 61 people in Hawaii. It inundated the coasts of New Zealand. It was a phenomenally big event.
As with the 2004 Sumatra tsunami, the Valdivia event was triggered by a megathrust earthquake.
Megathrust earthquakes occur on boundaries between oceanic plates and continental plates, where you have the oceanic plate subducting beneath the continental plate. And in this region, you can store a massive amount of energy over a large area.
That ocean plate that's diving into the Earth's mantle, it actually gets bent through quite a large angle. That causes huge stresses to build up within that plate.
When that stress is released, it does so violently.
So you get this movement of a huge fault at shallow depth beneath the ocean. And that's what causes a tsunami.
In 2004, the earthquake and resulting tsunami killed an estimated 230,000 people in 14 countries around the Indian Ocean. Part of the reason for the horrific death toll, people were not aware that a tsunami was coming and didn't expect one.
There was a real problem with education and preparedness in this case. So many of the people in that area weren't aware of tsunamis and didn't know to use the natural warning signs as a signal that they should evacuate.
A catastrophic tsunami wasn't expected in the region, even though there were warning signs.
There was evidence from geological studies of corals along the Sumatra coast, as well as historical accounts of large tsunamis. After investigating this, we did think that there was reason to have a warning system in the Indian Ocean, precisely because you could get these major events occurring there.
Early attempts were made to establish a warning system, but it was not felt as a priority.
It was going to take a while to get governments to pay attention to this when they had so much else to worry about in the Indian Ocean.
As the waters started to recede along coastal Thailand, the true scale of the devastation became clear. Nearly 8,500 people were injured in that country alone, many requiring severe medical attention.
I've gone by ambulance 6 hours the whole night, and now wait 10 hours and then 10 hours flight. I think then I will be really ill.
But among the havoc wreaked by the tsunami, there were those beyond the reach of emergency services.
When an earthquake happens, it can be devastating, but usually it's not such a huge area, and you have some idea of where the casualties are and where you need to rescue people. Whereas with the tsunami, they have these huge debris fields, and you have no idea where people might be either dead or alive.
Search and rescue crews combed debris, alongside volunteers and families searching for their loved ones. Family members posted flyers with pictures and descriptions of those missing.
At this point, we're hoping against hope that they're still alive somewhere, hoping that they're not unconscious and can't speak or something like that.
But within days, the chances of finding people alive faded dramatically.
I think after 5 days, I think they died.
Bodies continued to wash up on beaches 3 days after the tsunami. Rescue teams turned into retrieval crews.
Bodies can be swept quite long distances. Bodies can be trapped in trees, in branches, in brush, and indeed can be located in places where you would not expect to find a body. So you will often get a situation where bodies are recovered perhaps weeks or months later in unusual places that were not subject to a detailed search at the time.
都是尸体啊哈，所以没有什么困难性。那当然有一些被压住的哈，有的人被压住，树压住，啊，我们用锯的把它切开，然后它搬出来。
The dead were wrapped in tarps as workers sprayed chemicals to prevent the spread of disease. As the death toll climbed, the international impact of the disaster became clear.
Countries, let's say like Sweden, they had more people die from that event than any natural disaster they've had in their own country.
In Thailand, multinational forensic teams started the arduous process of identifying the deceased.
At this time, we have Australian team, German team, and French team. They can help us to identify all the foreigners.
It was a collection of 5,000 bodies in one place, all drowned, all black, all swollen, all looked the same. And you couldn't tell whether someone was from Africa or from Indonesia or from Thailand or from Sweden. They all looked the same.
Most of the people who die in this die from drowning, but also it's blunt force trauma. They get smashed. You get picked up by this thing, they get smashed into brick walls. A brick wall smashes into them because it's picked up by the tsunami.
คือจริงๆแล้วถ้าเผื่อเป็นฝรั่งนะฮะเป็นชาวต่างชาติเนี่ยมันจะมีพม่าด้วยนะฮะพม่าด้วยกะเหรี่ยงด้วยก็มีแล้วก็ฝรั่งด้วยอะไรก็คิดว่าประมาณใน 60%.
Initially, we were told we just need to separate the locals from the foreigners. The only time you could do that is if a particular local person had on a hotel uniform, for example, with a name tag or something that they belonged to a particular resort. So that was given up, and it was decided that all 5,000 bodies will be treated exactly the same. So every single person would have a forensic pathology examination, a forensic dental examination, a fingerprint examination. So the process started of one body at a time, doing those examination procedures. I couldn't even tell you how many dentists were on the ground at any one time, but it would have been 50 or 60, working out of a converted Buddhist temple.
With temperatures reaching 39 degrees Celsius, the waterlogged bodies were quickly decomposing.
And we had to convert this Buddhist temple into a makeshift mortuary with plywood walls and air conditioners.
Since the 2004 tsunami, authorities contacted over 4,000 relatives to come and receive bodies. However, not all could be identified.
There's probably 400 to 500 still unidentified bodies in shipping containers buried in the ground just north of Phuket to this day.
In Thailand, the tsunami killed around 5,400 people. But while the international media focused on tourists who perished in resorts, many locals were left to salvage the broken pieces of their lives.
มันหายไปหมดหายกับน้ำบ้านก็พังหมดพี่ก็ตายพี่สาวอย่างนี้ก็ตายบ้านก็พังหมดไม่เหลืออะไรทั้งนั้นนี่เสื้อนี่ก็แจกเมื่อวานนี่ก็นอนนี่นอนอยู่นี่ลูกนอนอยู่นี่
It sometimes takes great tragedy to forge a new path ahead.
I think the tsunami really was a catalyst for change in the way that the international community responds to large-scale disasters like this one.
The United Nations mobilized and secured agreement to establish an Indian Ocean tsunami warning system.
When this earthquake occurred, it was clear that we needed to be able to respond quickly and accurately to large earthquakes. When you have an earthquake of 5.5 and larger, it's observed by instruments all around the world. The initial alerts for earthquakes can come out in 5 minutes, but it's important to get that information out as quickly as possible for tsunami warning, to give people a heads up of what happened.
This boat can save a lot of lives for the people living in Indian Ocean.
The new system, which became active in 2006, can provide those around the Indian Ocean with the kind of warning that may have saved lives in 2004. In the advent of an abnormal wave, sensors on the ocean floor register a change in ocean pressure. This information is transmitted to buoys on the surface. Then a satellite which passes the data onto a monitoring center for distribution. As well as sending warnings out to the public, officials, and the media, the centers will record data that can influence evacuation plans and save lives.
The warning centers can then start to look at some of the models that they've run before. And they have taken those models to all the different coastlines that will be affected and show how bad that wave will be inundating that coastline. So immediately you've got a lot more information about where to evacuate.
In terms of tsunami safety and education, no other country is more prepared than Japan. Nestled toward the top of the Pacific Ring of Fire, Japan is a volatile hub of seismic activity. Minor tremors are almost a daily occurrence across the islands, with around 1,500 earthquakes striking every year.
2,500 dead and missing is the toll of the earthquake and tidal wave that swept over a 200-mile stretch of shore along the northeast coast of Japan.
Residents are trained to respond to tsunamis and the earthquakes that cause them. The country even has an early warning system. Earthquakes emit two types of waves: primary waves, which cause weak tremors, and secondary waves, which cause the bulk of earthquake destruction. The faster-moving primary waves can travel up to 8 kilometers per second. Seismographs on the surface register this motion, triggering alerts which are sent to homes, offices, and schools, providing precautionary instructions for the oncoming secondary wave. A warning such as this was transmitted across Japan in early 2011. On the 11th of March, an undersea megathrust earthquake measuring a magnitude of 9.0 struck 130 kilometers east of Sendai. It was the most powerful earthquake ever recorded in Japan. 373 kilometers from the epicenter, citizens of Tokyo received a minute's warning before skyscrapers began to sway. The earthquake was so intense, it shortened the length of the 24-hour day by 1.8 microseconds.
押さえたのさ、手で2つ。ところがこうなって曲げるんだよね。こいつ曲げてこうなってよ。あれの下になったんだ俺、ロッカーの。だけどちょうど机やったために、上さ机さこう倒れてながら、この子のすぐ前だから助かった。
The main rupture occurred over an area of only about 400 kilometers, and it had a huge amount of slip relative to previous earthquakes.
In the 2004 Sumatra earthquake, The maximum amount of relative displacement was around 20 meters.
The Japan earthquake caused 70 meters or more slip over that relatively small area. And because that slip happened right at the shallow part of the earthquake fault, it was very effective in generating a large tsunami.
地震とより大こう収まった時、その時ここから船に走っていって、そして船を大きさ出したの。津波来るんでねえかなと思ったから。
A Japanese Coast Guard patrol ship was one of the first to encounter the tsunami a few kilometers offshore. The wave continued toward the northeastern coast of Japan, where people were bracing for the impact.
Japan is the most tsunami-prepared country in the world. Was it prepared for the 2011? No. They had done modelling, and they had inundation maps, and they had evacuation centres. They had evacuation routes where you should go. Fundamental mistake they made was they didn't think there could be an event that big.
The initial warnings that went out talked about a wave smaller than the wave that was actually coming. Part of the problem was people not understanding what those wave heights were going to be, how far they had to go to be safe, and how quickly they had to do it. And in many cases, they had very little time.
Many of the tsunami shields offered little protection.
There are some places along the Tohoku coast where massive tsunami barriers have been constructed, and those were designed to prevent a tsunami of the maximum that was expected.
In some cases, the barriers failed completely.
And so those seawalls essentially became material for the tsunami to move around. They then became battering rams.
In Miyako City, tsunami waves reached run-up heights of 39 meters, as narrow bays focused the onslaught of water.
When a tsunami enters human population areas, the first thing it's going to do is essentially go along what is the path of least resistance, so it'll go up the rivers and it'll go down the streets.
Across coastal centers, people clambered atop buildings, hoping their structures could withstand the oncoming torrents.
When it comes across a building or something like that, it'll build up on that, just like when you see with a river in flood, it's flowing down, it's piling up and piling up and piling up, and if it has enough energy, that building falls over and it's gone. In the case of a tsunami, it is an incessant, continuing surge of water coming in, and it's picked up an awful lot of stuff to bring with it.
Desperate survivors in Kameishi watched as cars and fishing boats assaulted their places of refuge. Barely an hour after the initial quake, waves were surging over the Sendai Plains, 2 kilometers inland. Cars racing from the onslaught could barely move faster than the oncoming debris. In some places, the tsunami bore inland more than 5 kilometers, leaving a trail of utter devastation.
Starts off with total destruction, and as that starts to decrease, it starts to leave behind the stuff that it picked up as it started to move inland.
Across the world's most tsunami-prepared country, an area of approximately 560 square kilometers was inundated.
It's his house. Here.
Even people in some evacuation centers died, and they'd done the right thing.
Among the areas affected, at least 101 designated tsunami evacuation sites were hit.
この度の東北地方太平洋沖地震はマグニチュード 9.0 という例を見ない規模の巨大地震であり、被災地の悲惨な状況に深く心を痛めています。
The Tohoku earthquake shifted Japan's main island of Honshu 2.4 meters east. As the confirmed death toll began to climb, those unaffected prayed that lost ones would return.
はい、無事でした。なんとか、もうみんな親戚もみんな亡くなって、友達も。
45,700 buildings were destroyed, and 144,000 were damaged. Towns were transformed into unrecognizable rubble.
姉さんたちはしばらくて来れないから、私が今そこいらなんですよ、実家がね。
Sendai was in the direct firing line of both the earthquake and the tsunami. Days after the waves, industrial complexes still burned, fueled by ruptured oil storage tanks and liquefied natural gas stockpiled at the port. Over 4 million homes across Japan were left without electricity. In heavily affected areas, survivors searched in vain for missing relatives. International emergency crews combed through wreckage, marking empty structures with an X if they failed to find bodies inside.
And the idea is to slowly progress through all the buildings and vehicles to make sure there's no persons missing in them.
The earthquake and tsunami claimed over 15,800 lives. More than 2,500 on top of that were recorded missing. Amongst the severe pain and loss, there were a few stories of hope, as lucky families were reunited.
山回って来たんですよ。そしたらもう水もなければ、帰ってきたら水もなければ、もう全部バラバラになってしまって、今ようやく再開して、無事だっていうことで、子供たちだったら別だって、おばあさんが流されて一回アバランカを打って入院してるって、ただ奥さんがいないっていうことで今再開したんですけど。
帰ってる時に津波が来ちゃったんで、ずっと探してて、次の日から奇跡だと思います。
Scars left by the tsunami would take years to heal. However, the waves brought further destruction on the 11th of March. Some of the areas worst hit were about to bear the brunt of what was fast becoming a rolling disaster.
津波よりも一番怖いのは原子力なんですよね。
On the day of the tsunami, just 66 kilometers from Sendai, several thousand people were being ordered to evacuate. Multiple reactors at the Fukushima Daiichi power plant were going into meltdown.
There was a lack of understanding on the part of Tokyo Power and its regulators about the vulnerabilities associated with the plant.
The TEPCO plant had survived the earthquake, and the tsunami warning system had shut down the reactors, switching power for the cooling mechanisms to the backup diesel generators. But the generators were rendered inoperable as the waves swept over the 5.6-meter tsunami barrier.
Fukushima had a seawall. It just wasn't big enough. Simple as that. And again, this comes back to the fact that they were prepared for an event that was smaller.
In the case of the Fukushima reactor, the tsunami knocked out the auxiliary power supply, and so the reactor was not able to shut down and ended up, going into meltdown.
A total of 3 reactors at the plant started overheating. Pressurized hydrogen gas, building up in 2 of the containment buildings, caused a series of explosions. Radioactive material was now leaking from the plant. Workers toiled to cool the reactors with water cannons, and seawater dropped from helicopters. At the end of March, the evacuation zone expanded to 30 kilometers around the plant. Fractures in the plant's trenches and tunnels caused radiation to leak into the ocean. Close to the plant, levels of radioactive iodine-131 were measured at 7.5 million times the legal limit. The appearance of increased levels of radiation in some local food and water supplies prompted Japanese and international officials to issue consumption warnings.
だけど今後、今汚染された野菜、牛乳とかが出てきたって報道がもっと出てくれば自分飲まないかもしれませんし、本当に今日も雨ちょっと怖くって濡れたら大丈夫かなって濡れても大丈夫かなっていう不安は。
Lines stretched for blocks as parts of the country experienced food and water shortages for the first time since the Second World War. Farmers across Japan struggled as demand for their produce dropped, even in areas unaffected by the crisis.
これからね、風評被害とかそういうの多分あるかと思うんですよね。で、私ら農業やってますから、でそういう面で本当にこれからやっていけるのかななんていう心配あります。
Across the exclusion zone, crops and livestock were abandoned and left to die.
放射能が、自分の希望ですけども、大量の海水で中和されて、薄くなって、早く消えてくれればいいなと思っています。
In Sendai, the fishing industry collapsed, leaving many communities, already devastated by the waves, to grapple with radioactive emissions. On the 7th anniversary of the disaster, TEPCO revealed that it had reduced the rate of contaminated water reaching the reactors from 400 tons per day to 100.
前から比べればだいぶ環境も良くなって、安定してきてるというか、そういうふうに見えるんですけど、ただ、まだまだ先は長いと思うんで、今のところは今後どうなるかっていうのははっきり分かりません。
1 million tons of radioactive water still sits at the site, waiting for authorities to determine how to dispose of it. The Fukushima incident was the worst nuclear disaster since Chernobyl in 1986. A parliament-appointed investigation committee concluded that the disaster was man-made, the result of collusion between the government, regulators, and the operator of the plant, Tokyo Electric Power Company.
初歩的なこともできないような会社が原発を操業してたっていうことに怒りを感じて、直ちに電力会社を引きずり下ろしたいみたいな気持ちで、それでここに参加しました。
There was a reluctance on the part of the utility to address tsunami safety, in part because this seemed to be such a low probability event that its likelihood was discounted.
もちろんその作業というのは10年をはるかに超えて30年そんなことまで言われるような長い作業になってまいります。
Today, areas closest to the plant stand frozen in time as people fear to return to some sectors that the government has deemed safe. Japan will continue to carry the horror of the Tohoku tsunami for decades to come, but it has the wealth and facilities to slowly heal. For those in less economically stable areas, recovery is not always so certain. The 2004 tsunami ravished some communities around the Indian Ocean so badly that many would never be the same. Apart from the loss of life, the environmental and economic impact was enormous, requiring global assistance to rebuild. Rallying together, the international community donated $14 billion in aid across affected countries. In the 5 years following the tsunami, the International Federation of Red Cross Societies alone provided nearly 5 million people with assistance, rebuilding 51,000 new houses and restoring nearly 300 hospitals and clinics.
One of the issues also in the Indian tsunami was the state of the coastal mangroves and other ecosystems that were degraded. And so there was an effort to restore and to plant more mangrove forests around the coasts.
ผมไม่เคยคิดเห็นความสำคัญของป่าเลยไปเข้าในป่าก็ตัดโค่นสบายเลยแต่พอหลังเกิดสึนามิเนี่ยมันทำให้คิดว่าปลุกจิตสำนึกถ้าว่ามีป่าอุดมสมบูรณ์แล้ว
Revitalized mangroves create a buffer between communities and any coastal hazards.
There's now a big drive from many organizations to promote nature-based solutions or ecosystem-based approaches because it creates a lot of benefits, not only in terms of risk reduction, but also in terms of livelihoods and sustainability.
We like to empowering the people to look after their environment by themselves.
To effectively grow back communities, experts require a comprehensive picture of the destructive potential of seismically triggered waves. The first accounts of a tsunami date over 4,000 years ago. But in the last 2 decades, we've experienced 2 events unprecedented in scale.
We can't predict exactly how big and where an earthquake will be, but we can predict regions that are potentially closer to having a very large earthquake.
Earthquake-prone coastal areas need to look to recent tragedies and prepare for the inevitability of the next tsunami. While the Indian Ocean and Tohoku tsunamis left trails of disaster, they also provided data that could one day save lives.
We could trace the entire inundation of this tsunami all the way through 5 kilometers inland. We can now say to you, okay, once every X number of years, you're going to get a wave this big coming through.
We can only hope that we are better prepared when disaster strikes from the sea once more. When a tornado siren sounds, you're lucky to have half an hour to take shelter.
But a tornado can form and dissipate within seconds, and that's a very difficult forecasting challenge.
For some, the first warning is the sight of a giant gray vortex of extreme wind, twisting violently across the horizon.
Oh my God!
And then, catastrophe. Homes reduced to rubble, Cars tossed like tin toys, families torn apart.
Not many things are designed to withstand 200-mile-an-hour wind.
Scientists are still chasing answers to what causes the fastest winds on the face of the Earth.
We're trying to understand why some tornadoes become very intense and become the real killer F4 and F5 tornadoes that we're most concerned about.
We actually don't know some of the last processes that really make a storm form a tornado.
Unraveling the tracks of killer tornadoes may help us one day understand exactly when and where the next big outbreak will strike. Around the world, humanity exists only moments from catastrophe. Disaster bubbles below the surface of the Earth, strikes from the heavens, or engulfs us from the sea. But we are not merely at the mercy of our planet. In our pursuit of industry, global connectivity, and reach for the stars, lives have been lost. Disasters reveal the best and worst of mankind, as one tragedy compounds another. How do these disasters occur? And what lessons can equip us when catastrophe strikes again? The United States of America is a hotbed for tornadoes. More strike here than any other country on Earth. But the spring of 2011 brought devastation to numerous states in the biggest and most destructive outbreak in U.S. history. In an extraordinary 4-day stretch in April, 360 tornadoes ripped through multiple states, killing hundreds and racking up a $12 billion bill.
Oh! He's over! Let one go!
It was the second catastrophic outbreak that month. The first began as a strong low-pressure system traveled across the central plains of the U.S., pulling up warm, moist air from the Gulf of Mexico. As it interacted with a mass of cool, dry air blowing through from Canada, a line of supercell thunderstorms began to form, setting the scene for explosive, severe weather.
A supercell thunderstorm is a very strong and persistent thunderstorm. They can last for hours. The key ingredient is that they are rotating and tilted. These tilted, rotating thunderstorms we see in the high plains in Tornado Alley can last for hours and hours and sometimes produce multiple and violent tornadoes.
You need the air to be very unstable, and that means the air wants to rise violently. There's air that's very low density at the surface, and there's air that's very high density above. The atmosphere wants to flip, it wants to go up violently and change. You also need very strong winds.
If cool, descending dry air passes over rising, warm, moist air, it's the perfect setup for a flip. This happens in a normal thunderstorm, which can quickly kill itself off.
What will happen is that the rain will fall back down and kill off the original updraft, and you'll have basically a life cycle of a normal, what they call an air mass thunderstorm.
To brew up a supercell, you need an added ingredient of strong, multi-directional winds at different altitudes.
And then the real key ingredient is something that we call wind shear. So it's winds in the atmosphere that change speed with height, and they also change direction with height. Basically what it does is it creates rotation, but this rotation is horizontal. As you know, a tornado is vertical. So what ends up happening is this horizontal rotation, these supercells have very big, strong updrafts. Basically, it gets tilted into the vertical. So then you get the supercell, so you get this rotating thunderstorm.
And that rotation acts to bring the rain off to the side of the updraft and allows the supercell to exist as an entity much, much longer than an ordinary air mass thunderstorm.
Instead of cooling itself off, a rotating supercell just keeps on going.
And those are usually the strongest thunderstorms, and they're associated with the most severe weather. So winds, hail, and then tornadoes. And usually the strongest tornadoes come from these supercell thunderstorms.
Large tornado crossing the highway just in front of us.
And then it becomes a tricky part of how the tornado actually forms. So there's downdrafts and updrafts associated with this rotating part of the supercell. As this downdraft is coming down, it's bringing down rotation to the surface.
But only a small fraction of supercells produce tornadoes, which is another forecasting challenge.
On the 14th of April, the old river town of Poplar Bluff in Missouri copped a severe hailstorm. It followed a 4-day deluge that drenched the region with 15 inches of rain and broke the banks of the Black River. And then came the tornadoes, one after another.
These outbreaks tend to be a number of supercells that are spawning one after another tornado. That's why they're so destructive, because it's not like one and done. The tornado may dissipate, but then it's usually followed by another tornado.
Over the next 3 days, more than 150 tornadoes rampaged from Oklahoma to the Carolinas in an extraordinary severe weather blitz that killed at least 38 people, becoming the most active outbreak on record. In North Carolina, 30 tornadoes caused 22 fatalities, a state record. Days later, in a terrifying start to Easter, 2 large supercell thunderstorms moved into St. Louis, Missouri, sparking 5 tornadoes. The worst, a large E4, barreled through the terminals at Missouri's International Airport. 3 planes were on the tarmac, full of passengers, who rode out the most severe turbulence imaginable while still firmly on the ground. Outside the terminal, the extreme wind tossed vehicles about, including one van that was nearly pushed off the edge of an upper-level car park. A large section of the roof was torn off. Many of the glass doors and panes shattered. While many travel plans were shredded by the event, the biggest miracle of the Good Friday tornado was that no one was seriously hurt. A few days later, the super outbreak began to brew. A gigantic, long wave trough came in from the west, sending alarm bells ringing throughout the Central Plains. Weather forecasts look set for hell to unleash across multiple states. The Storm Prediction Center issued a particularly dangerous situation tornado watch for Arkansas, Missouri, Texas, Oklahoma, and Louisiana, part of the famed Tornado Alley.
The United States is really a great place for tornadoes because a lot of the key ingredients come together. And in particular, they come together a lot of times in the early spring in the central part of the United States, what's commonly known as Tornado Alley.
Much of the landscape is flat plains, as far as the eye can see, lying between 2 mountain ranges, the Rockies and the Appalachian.
It is just a hot spot where there's typically a lot of instability. There's a lot of wind shear, and it just is a prime area for very, very severe thunderstorms. Because we have the Gulf of Mexico, which has an enormous amount of warm, moist air that comes out from the south into the plains, but also the Rocky Mountains, which helps produce very cool, dry air that comes in aloft. It sets itself up for overturning. And that overturning, when the warm, moist air goes violently upwards, that's how you form a thunderstorm.
But uniquely in North America, there's an overlap between where that warm, moist air is flowing north from the Gulf of Mexico and waves that are still left over from late winter and early spring in the jet stream.
Jet streams are ribbons of wind that circle the globe at high altitudes, As they surge over the Rockies heading east, waves in the wind belt help deliver a good dose of spin and speed to the cool, dry air. This provides the wind shear and rotation needed for supercell thunderstorms.
If those ingredients all occur, then the Storm Prediction Center, which does forecast for tornadoes, will issue sort of an outlook that says this area looks prime for tornadoes.
On the evening of the 25th, the first tornado to cause multiple deaths hit Valonia in Faulkner County, Arkansas. It was an EF2 wedge tornado. Wedge tornadoes get their name because they're so fat and wide, they sometimes look like a block of black clouds jammed into the ground.
And they always say it sounds like a train. It didn't. It just was a loud wind. Our ears popped, and then just in seconds it was over.
Valonia is little more than a street in the center of farmland. The storm churned through the center of it, flattening mobile homes, flipping trailers and downing trees.
We need boots on the ground. We need people here with hands-on, moving stuff, piling stuff.
4 people were killed, a toll which could have been much worse had the town not received a 30-minute warning.
I think we're pretty good at trying to forecast supercells or tornadic thunderstorms. The difficulty is if that thunderstorm will produce a tornado and when will it produce a tornado. If you ask me what's that fraction, about 20 to 25% of all rotating thunderstorms produce tornadoes.
There is no long-range forecasting of tornadoes, only the conditions that make them likely to happen. The average lead time during the April outbreaks was about 25 minutes.
But then we have what we call the Storm Prediction Center. The SPC is looking at the weather everywhere, basically really only looking at the severe weather threat. So we're taking observations all the time in our atmosphere, and these are being fed into computer models. So we're watching these systems come across, looking for key ingredients that make up supercells, because supercells are what's going to make the strongest tornadoes.
Aspects of tornado formation remain a mystery, and the science of forecasting is relatively young.
But a tornado can form and dissipate within seconds, within minutes, and that's just a very difficult forecasting challenge.
Because they are so short-lived and unpredictable, getting clear images has historically been part of the problem. The 1957 Dallas tornado was a turning point in tornado research. As it churned a deadly 25-kilometer path through a metropolitan area, it was clearly visible for around 40 minutes. It became one of the best documented tornadoes. More than 100 people caught it on film. From these clips and other photographs, scientists were able to estimate wind velocities and the speed of the tornado. Engineers were also able to relate those speeds to damages on the ground. In that storm, 500 were made homeless, 200 injured, and 10 people perished.
Most of the reports of tornadoes came from unscientific observation. They'd go out and interview the farmer, what happened here? And the farmer would say something like, well, we lost the roof in this house, and for some reason here, my chicken was completely plucked after the tornado went through. And then have to figure out, well, what is the wind that it would take to pluck a chicken? Those kind of things, right? By the early 60s, the interstate highway system had been completed in the U.S., and so it became possible to navigate your way to a thunderstorm and start making scientific observations. One of the researchers there, a guy named Neil Ward, was the first person to get the idea to get in his car and chase after a thunderstorm. What he found is that there is a very characteristic set of events in these thunderstorms that precede the tornado formation. For example, they find that there is a cloud base And before the tornado forms is a lowering of the cloud base called a wall cloud. Then there's a rain shaft that is basically on the backside of the wall cloud. So there were just a number of scientific observations.
The study of tornadoes took a huge leap in the 70s when a team of scientists first managed to intercept a tornado with an experimental Doppler radar. On May 24, 1973, conditions in Oklahoma were lining up for tornado formation, and an array of instruments and cameras were set up in the field, ready for the chance.
There was a severe tornado case, and it actually led to the development or formation of the National Severe Storms Lab. They chose a good location.
Right on cue, an F4 tornado ripped through the farming town of Union City, and for the first time, scientists were able to capture its entire life cycle with radar, from start to finish. It changed tornado forecasting forever.
The National Severe Storms Laboratory is a national laboratory funded by NOAA, which also funds the National Weather Service, the Storm Prediction Center, the Hurricane Center, all these groups that are associated with forecasting weather. But the Severe Storms Laboratory focuses on research which can be very quickly applied to making better forecasts of tornadoes and other severe storms, including hailstorms and flash floods and other phenomena.
Doppler radar scans of the Union City tornado led to two critical discoveries: that rotating thunderstorms could lead to tornado formation, and that a tornado vortex signature, a strong radar indication of circulation, often appeared about 25 minutes before the tornado. Here, they had two critical potential warning devices, which could save many lives. Just 1 year after the Union City tornado, the super outbreak of 1974 occurred. It remains the deadliest spate of U.S. tornadoes on record. As the National Weather Services were still using 1950s equipment for forecasting, warnings were virtually non-existent. It was a particularly violent outbreak, carrying with it 30 EF4 and EF5 tornadoes. 335 people were killed and 6,000 injured.
Sounded like a big train whistle, and we were right underneath the front of it. I've never seen anything like it, and I don't want to again.
Although a horrendous toll, the 1974 outbreak brought critical changes that saved lives in the future.
I don't know. It was just terrible.
Most importantly, money for tornado intercept research increased.
What can you do? We've lost everything that we've had.
Secondly, they brought in the Fujita scale as a standard language for scientists to discuss and reference different strength tornadoes.
There's something we use called the Enhanced Fujita scale. Really what it is it's a damage-based scale. So looking at damage, wind speeds are inferred.
Tornadoes are rated by the amount of damage they do. So if tornadoes break a few branches, they're F0 or F1. If they completely wipe houses down to their foundation, so there's nothing left but the slab, that's an F5. In between, there are different levels of damage, from lifting off a roof, maybe that's F1, to removing a bunch of walls, that might be F2. There are a lot finer details than that, but roughly it's the level of destruction that a home or other structure experiences.
If a tornado has ferocious winds, but lands in a rural area with no destruction of property, they will receive a low rating, even those that normally cause the total obliteration of well-built structures.
So if a strong tornado with 400-kilometer-per-hour winds goes through open wind fields, it's rated F0. In some sense, that's kind of silly because we know it's much stronger than that. Even if we measure winds stronger than that with a radar, it's officially rated F0 because of the damage. We are working with the American Society of Civil Engineers to develop a standard that uses all available evidence, including damage, radar measurements, anemometers, to try to come up with the most comprehensive and most accurate measurement of tornado winds.
Although only around 1% of tornadoes in the US are classified on the top end of the scale, an EF4 or EF5, the majority of deaths are in these two classes. Any tornado that has a greater chance of hitting an urban area is likely to be higher rated, do more damage, and kill more people. With the advent of the Doppler radar, it's become possible for researchers to measure the extreme speeds of tornado vortexes. Doppler radar uses microwave beams to sweep through storms. These microwaves can be reflected off particles such as rain, hail, and other debris. The radar uses the Doppler effect to work out which direction and how fast these particles are traveling, by how they change the reflected signal. If the object is moving away from the antenna, a lower frequency signal is detected. Higher if the object is moving towards the antenna. A computer translates the information into a visual representation, where different frequencies are viewed as different colors, representing speed and direction.
I lead the Center for Severe Weather Research, which operates the Doppler on Wheels mobile radar fleet and also other instruments that we drop in front of tornadoes, hurricanes, other kinds of interesting weather. We've compressed everything and made it rugged and mobile so we can chase to the weather. We can go to tornadoes instead of waiting for them to come to us. By getting up close, we can see the fingerprints, the small details that you just can't see from farther away. We're trying to understand the map of the winds inside tornadoes. Where are the strongest winds? How are they doing damage? We're trying to watch the birth process of tornadoes and understand why some thunderstorms produce tornadoes and some don't. We're trying to understand why some tornadoes become very intense and become the real killer F4 and F5 tornadoes that we're most concerned about.
Using radar, wind speeds of incredibly destructive strengths can be measured.
We try to get really close, and what we could do is we can map out the 2- and 3-dimensional structure with the radar. And the closer you get, the lower down you can look inside the tornado, and the closer you get to the surface, those are the winds that are actually really impacting buildings and structures and people.
Perhaps the strongest winds produced on the face of the Earth is associated with tornadoes. Recent studies using mobile Doppler radars have documented unambiguous winds of around 135 to 140 meters per second, almost 300 miles an hour winds. It's an amazing number. The fascinating thing is the tornado, how can it produce such a strong wind locally compacted at the base of the funnel of a tornado? There's a very good radar network across the U.S. now. You can actually see rotation in the storm, which is also an indicator of tornado genesis.
Rotation in a storm can be seen as a characteristic hook, the tornado itself as a coupling of green and red intense bands. Doppler radar can also help forecasters identify tornado signatures, like debris balls, which are areas of high reflectivity, where debris is carried aloft in the tornado. Particularly strong tornadoes can have massive debris balls, like the EF5 Bridge Creek tornado.
One of the strongest tornadoes we've ever observed was in central Oklahoma, near Bridge Creek and Moore in 1999. That tornado went directly through a metropolitan area, so had very high impact, killed almost 40 people, destroyed thousands of homes, just this one tornado. And we measured the strongest winds we've ever seen, or I think anybody has ever seen, over 300 miles an hour, almost 500 kilometers per hour. The damage in that tornado was not just F5, it was very, serious F5 level damage. Homes were just wiped and scoured off their foundations. Fields and lawns were scoured with the grass removed. It was a very dramatically strong tornado that caused bad impacts, strong impacts to the areas it hit.
I walked into the tree line, caught a movement out the corner of my eye. Under some debris around the base of a tree, I seen what appeared to be a baby.
Oklahoma City is near the heart of Tornado Alley in the US, and Moore has had its fair share. Being struck more than 20 times by tornadoes, a number of them particularly violent and destructive. On the afternoon of May 20th, 2013, another long-lived EF5 tornado mowed through the town. Whole neighborhoods looked as though they'd been thrown in a blender. So unrecognizable that street signs had to be urgently printed so that rescuers could map out where they were. In the direct path of the tornado lay 2 elementary schools. Parents arrived to pick up their children from school, only to discover in horror that virtually nothing was left of the buildings. Miraculously, no one died at Briarwood Elementary, but 7 children perished at Plaza Towers. Neither of the schools had shelters. After the devastation, there was an outcry for change. School districts across the state called for greater funding to afford every at-risk school a tornado shelter. EF5 tornadoes are extremely rare, but the super outbreak of 2011 had 3 and 12 EF4s, which helps explain why such widespread destruction occurred. Most of the violent tornadoes struck on one awful day, April 27, with more than 300 deaths occurring in the space of 24 hours. Alabama bore the brunt of it.
The 2011 outbreak was largely in the southeast. Tuscaloosa and Birmingham were particularly hard hit.
In Tuscaloosa and Birmingham, the first wave brought nearly 3 dozen twisters that morning, knocking out communications and power. Few expected a second round of supercells were about to whip up the most violent and long-lived tornadoes. That afternoon, an incredibly wide EF4, which spanned more than 26 football fields, churned across 130 kilometers of landscape. Wind speeds were greater than 300 kilometers an hour. 65 people were killed in that single event. The cost of simply removing the extensive debris from Tuscaloosa was estimated at $100 million.
I'm grateful that we survived it, but it was one of the most horrifying experiences I think I've ever experienced in my life.
Sometimes that surprises people because people say, well, that's not Tornado Alley. Tornado Alley is Texas, Oklahoma, Kansas, Nebraska, Iowa sort of area. But actually down in the southeast, they can get pretty severe tornadoes too.
Alabama lies in the tornado-prone Dixie Alley, a loosely defined southeastern region. Although it gets less tornadoes than the better-known Tornado Alley, generally, they are longer-lived. Dixie Alley is the deadliest region for tornadoes, but this is not based on wind speeds alone. Dixie Alley bucks the seasonal trends for tornadoes. They can even occur in winter. Many also happen at night. This leaves people less ready to respond to a warning, more likely to be taken by surprise.
I knew I was in deep trouble when I saw the building coming apart across the highway here. And the next thing I knew, I was rolling.
Half of the nation's mobile homes are located in the southeast.
I had lived in the trailer east of you. Unfortunately, I was lucky, just twisted the top off of mine.
According to the Storm Prediction Center, most tornado deaths happen in mobile homes.
But unfortunately, my brother wasn't so lucky. Tornado hit it and tore it all to pieces.
Which are far less structurally sound than a well-built house. Dixie Alley also has a different landscape. Much of it is covered in trees, is hilly and humid. Clouds hang lower, and tornadoes can be harder to see. Because Dixie Alley is closer to the Gulf, it also increases the likelihood of violent, rain-wrapped tornadoes.
Rain-wrapped tornadoes is literally where there's a curtain of rain that just sort of wraps around the tornado, so it's a good descriptive term. The danger with that is it often hides the tornado visually. So if you're not fortunate enough to have a radar with you, for example, you may not even see the tornado and not realize it's right behind this curtain of rain.
How big a tornado actually is seems to be as much a matter of opinion as it is science.
Defining tornado size is problematic because everyone has their own definition. People who are out chasing look at the condensation funnel and say, that's how wide the tornado is. Worse, they're just looking at it and estimating and saying, that looks 2 miles wide. It's very crude, just eyewitness reports of what they think they're seeing. The Weather Service rates tornadoes by how wide a swath of damage they make. My team rates tornadoes by how big the wind circulation is, because we're making detailed maps of what the winds are. Still, some tornadoes are much, much wider than others. The widest tornado that we've ever documented, and we're in agreement with other methods of documenting width of tornadoes, was back in 2013 in central Oklahoma, near a town called El Reno. And that tornado had a width of damaging winds that we mapped that at times was 4 or 5 kilometers wide. It was extremely broad. But this was a very complex tornado. It didn't just have a single swirl of wind. Inside that were these other most violent features of the tornado that were spinning around it.
Like many multi-vortex tornadoes, the El Reno twister proved to be highly unpredictable, dangerous, and difficult to navigate.
The tornado essentially breaks down into multiple funnels, all rotating around a common core. That actually happens fairly commonly with all tornadoes. Perhaps the unique aspect of the El Reno tornado is because the tornado itself was very large. These multiple funnels or suction vortices were also very large. It was one of the largest funnels ever. It was, we believe, an EF5 tornado, but it actually was rated EF3. There was some controversy about that.
Although El Reno was only initially rated an EF3 because of the damage, individual vortices were some of the strongest ever recorded. The highest measurement of 475 kilometers an hour was the second fastest wind speed measured, just below the Bridge Creek tornado. The twister killed 20 people, including a team of researchers attempting to document the tornado. One of the most famous and deadly multi-vortex tornadoes descended on the western edge of the city of Joplin, Missouri, on May 22nd, 2011.
The Joplin tornado is well known because it went right through a medium-sized, small city.
Back up. Oh, no.
And it turns out to be the 7th deadliest tornado in history. Why that's remarkable is the other tornadoes that were in that same ranking occurred many, many years, decades ago. So you would think with all the new technology, with all the new computers, with all the new satellite technology, how did we have an event that ranks number 7 on the fatality list of tornadoes?
The EF-5 touched down at 5:41 p.m. on a Sunday evening, and weather services knew in advance it was coming.
Why so many people died? Turns out it wasn't because the forecast was bad, because that might be one of the first guesses. Well, the forecast must have been terrible. They had no warning. They had actually quite a bit of warning. It turns out that a large part of this was the social response from the people. They went back and checked, and a lot of the people that heard the alarm go off waited to hear another confirmation. Somebody calling them to confirm that you better get out of the way, or watching on TV to see maybe a TV weather forecaster to come on. That delay of waiting for a second confirmation was not good. People needed to move, and they needed to move very quickly.
Joplin residents had almost half an hour to take shelter, but many didn't heed the warnings because they'd become desensitized to sirens.
I heard him screaming, Chris! Kathy, where the stuff? Kathy, somebody in here!
There's always a worry that you're crying wolf too much. That's been one of the hardest things to sort of reduce the false alarm rates.
Oh, come here, sweetie. Come here, honey. Come here, sweetie. It's okay.
It's not just hard science research. There's a social science aspect of how people react to warnings. And with the Joplin case, that couldn't be better illustrated. And that is what led to so many people dying. They simply didn't get out of the way when they were warned well ahead of time.
It hit a substantial part of the town, so residential places, commercial places, and then also the Joplin Hospital was also impacted by that tornado.
Views of the damage from the air give an idea of just how big and destructive the multi-vortex tornado was. Entire neighborhoods were blown away.
What we say about suction vortices is that if you've looked at aerial damage photos, oftentimes you sort of see marks like this along a tornado track. So I often call them spirograph marks, because that's literally what it is. And that's where the biggest or the strongest damage tends to occur.
In 40 terrifying minutes, it devoured more than 7,000 homes, nearly 500 businesses, and claimed 161 lives.
I had done an analysis several years before asking what if? What if a Joplin-like tornado, what if a strong tornado like we had seen in Bridge Creek or even El Reno went through St. Louis or went through Chicago or went through Atlanta? And the what if consequences were huge. You could damage 50, 100,000 different homes. Potentially you could kill 1,000 people if you went through the suburbs of one of these large cities. That was very hypothetical until we had seen Joplin. If the Joplin tornado had occurred just 50 miles from where it went through Joplin, if it had gone through suburban St. Louis, you could have had outcomes much worse than that. And that was very sobering for those of us who were looking at these worst case kind of what if scenarios.
Some scientists actually questioned whether the F5 was a high enough rating on the Fujita scale, or whether we actually needed a higher rating on that scale, to put into context how big that tornado really was. And the Joplin tornado was especially devastating in that it destroyed approximately 1/3 of the physical landscape. Joplin is characterized as a near-miss event because it actually occurred on a Sunday. Had the Joplin tornado occurred on a school day, school administrators there after that terrible storm acknowledged that many school children likely would have perished in the Joplin schools that were so badly devastated in that tornado event.
The giant tornado caused damage to around 3/4 of Joplin's buildings. The following day, Missouri Task Force 1 was sent in to start clearing up the damage and searching for missing persons.
I hope you do find somebody. Find information. Write it in a marker on their head. If they do not have a head or a proper place to write it on their torso. I don't want to see any information on their limbs. Okay. Don't worry about desecrating somebody's loved one. You're not. You're giving us information so we can get the loved one to them. They'll clean them up before they see them. Okay?
Dog teams scoured piles of rubble to try to establish where people lay buried.
Everything's gone.
Nothing's ever gonna be the same again. Nothing's ever gonna be the same again.
Even as scores of volunteers arrived to help clean up the disaster, the city remained in a state of high alert as storms gathered on the horizon once more and began to pummel the city. Although they can bring the highest wind speeds known to man, the chances of surviving a severe tornado are high if the warnings are heeded.
When there is a warning, that means a tornado either is coming towards their area or might come towards their area very soon. And they should take action. They should take reasonable action to either get to an interior room of their house, or if there's a community shelter, if they're living in manufactured homes, get to one of those community shelters that's stronger. They should, as much as possible, really try to stay calm and organized. It's when people panic, people start to make poor decisions. They either try to run away or they don't pay attention and they watch it. They get mesmerized and stare at it. Or they go into a ditch where it might flood.
You know, a lot of people drive towards it because they want to get a better look. The sensible thing to do is try to get away. You know, not many things are designed to withstand a 200-mile-an-hour wind. If you have a hole in the ground to crawl into, you should do that.
Quick thinking may have saved many children during a deadly tornado outbreak in Indiana, March 2012. At least 10 tornadoes touched down in Indiana. One of them, a direct hit on Henryville High. Luckily, the school had evacuated its pupils before disaster struck, but some were still on the way home in a school bus. Surveillance video from inside the bus shows what may have been in store for the students had their bus driver not raced the storm and made it back to the school and under cover 3 minutes before the twister struck. The empty bus was blown into a building, but no one was harmed.
Of course, that isn't the place you want to be. Any vehicle is not good in a tornado.
The tornado ran for a remarkable 77 kilometers and lasted almost an hour, hitting not just Henryville, but several other locations in its path. Right after it passed through, an EF-1 was hot on its heels, churning through almost exactly the same track. As if the two tornadoes weren't quite enough, baseball-size hail also came down, the largest ever recorded in Indiana, 12 centimeters in diameter. One of the most tragic stories to emerge from the disaster was the near-miracle survival of little Angel Babcock. The toddler was found barely alive in a field after the tornadoes had swept through. Her entire family had been picked up by the vortex and dropped 100 yards from their home. All were dead, except little Angel, who spent 3 days in critical condition before being taken off life support.
Oh, they loved her. I mean, we all loved all those kids.
The severe outbreak that early March also hit Kentucky, Ohio, and Alabama, killing more than 40 people. Each year, seasonal outbreaks across the U.S. bring their own set of tragedies, but even forecasters were shocked by how severe April 2011 became. The total number of tornadoes spawned that month, more than 750, represented nearly a 5-fold increase on the norm. Why these outbreaks spawned so many tornadoes is not certain, but recent research suggests it could be part of a disturbing trend. In 2014, a Columbia University study found that the number of tornadoes and extreme outbreaks has jumped dramatically, roughly doubling over the last 50 years. Could this be due to climate change?
Do we see a very distinct relationship between tornadic activity and climate change? And the answer is no. If you ask me, has there been any change in recent years about tornado activity? And the answer to that is yes. There seems to be more tornadoes than outbreaks. The number of tornadoes in an outbreak have gotten more extreme, but no one has been able to link that to climate change.
As the world warms, the oceans are also warming, which adds to the amount of moisture and energy powering storms.
Tornadoes are much trickier to deal with. Tornadoes come from supercell storms. The climate change element is adding a little bit of extra instability. It's making the potential for a supercell thunderstorm to be a little bit greater. Whether the wind shear occurs or not is a bit of a crapshoot. I don't think that has much to do with climate change one way or the other. But when the tornado outbreaks have occurred, they tend to be a bit bigger and more damaging in recent years.
While the Columbia team found no evidence of increasing instability over the US, they did find a substantial increase in storm relative helicity, the potential for rotational storms to occur due to wind conditions. Current models don't suggest this will increase in a warming climate, so the cause remains a mystery. While tornadoes are the main subject of much passionate and focused research, many aspects of their genesis remain unknown.
What I find interesting about tornadoes is they're a little difficult to predict, so there's an element of surprise about them, and you don't know sometimes if tornadoes are going to be really strong or really weak. We actually don't know some of the last processes that really make a storm form a tornado.
We've made some major progress in understanding tornado structure. We've made progress in understanding some of the important processes involved with tornado genesis, the birth of tornadoes. So we know what days have enough energy for thunderstorms to form. We know which days we're going to get waves in the jet stream. What's not so good are the details, and of course those details are what matter to people living in the paths of the tornadoes.
For those that live in the path of tornadoes, there are many questions that need to be answered to adequately know the difference between a bad storm on the horizon and imminent destruction.
The details are when exactly are the tornadoes going to form. Of those 6 different supercells, which 1 or 2 are going to make the tornadoes? Of those 1 or 2 that are going to make the tornadoes, when during their 1 or 2 hour lifespan, and exactly what track will they take? Those are the details we don't know. And those are the details that we're really trying to learn.
I'm fascinated by tornadoes because they're so unpredictable, they're so powerful, and they really affect at least a part of the population.
The questions burning in the minds of tornado researchers, who often risk their lives to answer them, have already saved countless people. In the last half-century, the improvements to detection and warning systems mean typically many less people die each season, despite an exploding population. Even to those who live in the bullseye of Tornado Alley, cars, guns, and fire remain a much deadlier daily risk than a tornado.
You know, the thing why people don't lose too much sleep about it is because the probability of you being hit by this little tiny funnel over this great expanse of territory is small.
A giant howling vortex of thunder and rain, spreading its spiral arms in a destructive embrace. It can reach more than 1,000 kilometers.
I feel like we've lost our city.
This is a tropical cyclone.
It's just this massive roar, and it hits like a freight train.
The winds can be deadly, but the storm surge even worse.
I got nothing left.
My initial impression was just one of complete and utter devastation.
It makes it a huge humanitarian problem,
and a huge technical problem. Just how do you clean up this?
As storms intensify and urban populations explode, we're more at risk than ever before.
Hurricanes are getting more intense and longer lasting.
The casualties more or less 10,000.
Sifting through the wreckage of some of the world's biggest disasters, we can find the clues to predicting and surviving one of the most extraordinary forces of nature. Around the world, humanity exists only moments from catastrophe. Disaster bubbles below the surface of the earth, strikes from the heavens, or engulfs us from the sea. But we are not merely at the mercy of our planet. In our pursuit of industry, global connectivity, and reach for the stars, lives have been lost. Disasters reveal the best and worst of mankind, as one tragedy compounds another. How do these disasters occur? And what lessons can equip us when catastrophe strikes again? The southeastern states of the US are famous for their laid-back lifestyle, cradling the warm blue waters of the Gulf of Mexico. But the tropics attract more than just beachgoers and tourists. They're the breeding ground of some of the world's most ferocious cyclones.
We're just trying to get as far away from here as possible.
So in different parts of the world, they call it different things. In Australia, it's called a cyclone. In the USA, it's called a hurricane. In Mexico, it's called a huracán. In East Asia, it's called a typhoon, but it's all the same thing.
Hurricane Katrina was born as a tropical depression. On August 23rd, 2005, just near the Bahamas.
When these cyclones form in tropical areas, they get what's known as a warm core. So the air rises up around it and then starts to sink, hence forming the eye of a cyclone.
High rates of evaporation drive the movement of warm, moist air up into the atmosphere.
So the oceans need to be around about 27 degrees Celsius, and you need upper atmospheric conditions to be favourable to allow that air to rise and then diverge or spread out.
A lot of it has to do with low wind shear, meaning that there's no strong winds at different levels of the atmosphere.
There are no major damages so far, mainly tree debris and power lines that were blown down.
Warm waters are the fuel source of tropical cyclones. As the air at the ocean surface moves upwards, pressure drops and more moist, warm air is sucked in to replace it, creating a vortex of intense winds. As cyclones travel over tropical waters, they can rapidly intensify and grow.
It was after Katrina traversed South Florida and came out over the Gulf of Mexico, where there were some very high sea surface temperatures, that it began to really develop.
You have an obligation to yourself and your family to haul ass and get out of here. And I'm telling you to get out now.
In the Gulf, Katrina morphed into a monster, with winds surpassing 175 kilometers an hour.
It's better to be safe than sorry, and I'd rather prepare early than be without when the time comes.
Hurricane Katrina was a massive storm. At one point, it was a Category 5, and it filled the entire Gulf of Mexico.
Katrina then went through a distinctive transformation before it reached the coast.
So you have these spiral armbands that sort of wrap around the storm, and if the spiral armband gets wrapped around so much, it can actually shut off the eye wall. and then the old eye wall dies, and a new eye wall forms. This is one of the processes that makes the storm bigger.
Katrina weakened to a Category 3, but grew in size.
And it stopped intensifying, and then it just started to spread out. And the wind field became very large at that point.
Nestled on the banks of Lake Pontchartrain, Louisiana's biggest city, New Orleans, was directly in the eye's path.
If you look out and you see the level of the lake and look at the houses, the lake is above the houses.
A mandatory evacuation order was executed, the first in the history of the city. Residents were given plenty of warning. A big one was coming. But nothing prepared them for what was in store.
The estimates are that somewhere between 100 to 120,000 residents of the city of New Orleans either could not evacuate or chose not to evacuate in advance of Katrina's landfall.
Katrina was sort of two disasters at once. So there was a sort of traditional hurricane disaster that happened on the Mississippi coast. Mississippi was to the right of the center. The winds were blowing onshore, and they had an unbelievable storm surge that inundated all those coastal towns. New Orleans was on the western side of the center, and their wind was blowing from Lake Pontchartrain into the city.
When the storm surge flooded into Lake Pontchartrain, the levees couldn't take the strain.
So when they gave way, there was really nothing to stop the water from just pouring in. My understanding is most of the people drowned one way or another. It was the water inundation that killed people.
Storm surge is one of the most deadly effects of tropical cyclones. Although Hurricane Katrina weakened to a Category 3 before landfall, its enormous size displaced huge volumes of water.
We saw tidal surges, water, cover things that just amazed me.
One of the things that really blew my mind about Katrina was how much of the US coast had impacts. Basically from Louisiana almost to the Florida Panhandle had sustained hurricane force winds.
This was a 4-story condo complex with parking underneath.
Send a lot of help.
Storm surge prone area like the Northern Gulf, you start piling up a lot of water along the coast and carrying a lot of water with the center of the storm.
In the end, it affected an area of land of about 90,000 square miles, which is about the size of Great Britain.
6, 5, 4.
Tropical cyclones are most easily studied from space. And NASA has an arsenal of sophisticated instruments to help track and predict their formation and path. The Terra and Aqua satellites analyze rainfall rates, temperature and humidity, as well as surface wind speed, cloud height, and ocean heat. Closer to the ground, hurricane hunters carry out riskier missions.
So the mission purpose today is to stay in the environment as long as humanly possible.
Storm penetration is done by Air Force C-130 as well as the P-3 aircraft from the National Oceanic and Atmospheric Administration. And the flight tracks are designed to find the center And you're not going to find the center unless you actually go to the center, and that means penetrating the eye wall.
While the eye wall of the storm contains the strongest winds of the cyclone, the center, the eye itself, is an oasis of calm.
The eye of a hurricane is one of the most surreal experiences. To get into the eye, you've got to get through the worst part of the storm. So you're shell-shocked from this constant roaring of wind.
And all of a sudden it's calm. You can dash outside quickly if you want to, but then you can hear the return eye wall coming.
Hard to believe this is a street, isn't it?
And it hits like a freight train.
Cyclones are rated according to their wind speeds. In the Western Hemisphere, they use a classification called the Saffir-Simpson scale. Between 120 and 150 kilometers per hour, hurricanes are a Category 1. At Category 3, the level of Hurricane Katrina, major damage is expected. Trees will be uprooted and large-scale destruction of infrastructure may occur. The highest rating is Category 5. It's applied to any hurricane over 251 kilometers an hour. Little can withstand this type of hurricane.
The number of the Saffir-Simpson scale is related to wind only, and it really doesn't convey the entire threat. There are many other threats associated with it that sometimes are proportional to that scale and sometimes not.
Cyclones don't need to be large to create massive, deadly storm surges. Take Super Typhoon Haiyan, the fiercest tropical cyclone to ever make landfall. In 2013, it hit Tacloban City in the Philippines at a Category 5 rating. The most severe wind category possible. More than 6,000 people were killed.
Please contact this number so that we can also get him.
The media and people have a way of confusing the intensity of a storm with the size. So they say that Super Typhoon Haiyan was really large. Actually, it was the opposite. It was a very small typhoon, but it was very intense.
That Philippine Sea area, if there's a bathtub of hot water on the planet, that is the place.
The sea surface temperature where Haiyan formed was around 30 degrees Celsius. With a lack of wind shear, there was nothing to slow it down. Winds were measured at a sustained speed of 305 kilometers per hour. But momentary gusts reached 380.
But it was hard for anything to actually report a wind in that kind of environment. Almost no measurement device will withstand that. So it's kind of hard to tell.
Haiyan smashed into the Philippines at near peak intensity, with 25 million people in its path.
So I picked a hotel right in the center of the city, a big concrete hotel, and that's where I decided to hunker down for this typhoon.
The wind's starting to make that moaning sound. I think maybe we're just starting to get in the cyclone circulation.
It was utter devastation. Tacloban almost was wiped off the map.
Starts out, it's just windy, rainy, messy weather, and then it gets worse and worse. And finally, when you get into the inner core of the hurricane, or what we call the eye wall, that's when things go nuts.
The building's getting torn apart.
The eye wall is the area of strongest winds, right at the center of the cyclone, where moisture-filled air is rushing upwards at phenomenal speeds.
The rain is so heavy and the wind is so violent that everything just turns white. It's a whiteout. debris flying everywhere. I mean, stuff smashing into buildings. The kind of stuff that if it hit you, it would kill you instantly. Tacloban City is on the tip of a peninsula at the top of a very narrow bay. And what happened was the center passed south of the city, then the wind shifted to the southeast, and basically had all this wind forcing all of this water into this narrow bay. And then all of a sudden it just overflowed into the city. And it swept the entire downtown area. It was literally like a tsunami. And it happened so fast that thousands couldn't get out of the way in time.
We have an estimate given on the casualties, more or less 10,000.
Nothing was ever like Haiyan, and I have not seen anything like it since. To see a city of 220,000 people just destroyed, whole city blocks just gone, piles of rubble, bodies in the streets. Of course, you expect to see emergency services, first responders out, helping people who were injured or rendering aid. That was not the case here.
Sa mga news, sabi daw, meron ng mga relief. But sadly, walang dumadating sa amin.
Magnitude of this catastrophe was so huge that society was paralyzed. There are no sirens, there's no traffic through the streets. Well, there can't be because the streets are blocked with wreckage. There's just desperate residents trying to dig through the rubble. It is one of the saddest, most awful things I've ever seen. A complete breakdown of infrastructure, of just basic city services, hospitals overflowing with injured people. I never saw something so grim or desperate. Haiyan was just, it's burned in my memory.
Almost 1 million people in the Philippines were made homeless by the disaster. As shortages of food, water, and medicines drove the population to despair, thousands stormed the local airport on November 12th. They broke down fences, struggling to board planes. Aid trucks were attacked and their food stolen.
It's chaotic. I don't know where to go. We don't know where to go to get any food.
Troops were sent in and a curfew put in place to try to restore order. A week after the cyclone hit, Tacloban began the terrible task of burying their dead. Bodies lined the foreshores of the wrecked city to be photographed, labeled, and buried in a mass grave.
This happens a lot of places in the world where there are lots of poor regions. The structures are not well constructed, and they don't last at all. And the people, if they are able to get out, they have nowhere to go.
In a situation like this, nothing is fast enough. The need is massive, the need is immediate, because everybody, all at the same time, is hungry. All at the same time have no water. All at the same time have no communication, no power.
And so it makes it a huge humanitarian problem and a huge technical problem. Just how do you clean up this? What do you rebuild? There are pictures of weeks and months later in Tacloban of complete devastation still there. It was very hard to gather the resources to begin the cleanup and the rebuilding process. The resources were just not there.
The day after Hurricane Katrina passed, residents across the Gulf states emerged to assess the damage. Although spared a direct hit, the worst was yet to come for New Orleans.
The water just come up, I mean, just out of nowhere. And everybody here was trying to head for higher ground, and there is no higher ground.
Some of those people who didn't evacuate because they didn't think the hurricane was going to be as bad as it was, they weren't necessarily wrong. Because much of the flooding and destruction that happened in New Orleans was because of the levee system that failed.
Until the levees were repaired and Lake Pontchartrain tamed, the city would remain submerged.
The sand layer was 3/4 of the way up to the ceiling, which showed us that it was a phenomenal force of water going through those houses.
The debris doubled in its size, so it's only a matter of time for the levee to completely disintegrate in front of us.
The levees were designed and built by the U.S. Army Corps of Engineers to protect the city from flooding. But even they knew its limitations.
The US Army Corps of Engineers had done experiments on these levees in the 1980s and knew that the type of levees that they had built would burst once the water got up to a certain level.
Within 24 hours, there were more than 28 reported breaches of the flood barriers.
Not all of them collapsed. Some of them didn't meet up with other parts of the canal walls because one part was owned by one government department, another part was owned by another government department, and they didn't see eye to eye for various bureaucratic reasons, and so they never joined them.
So that in some parts, 80% of the city was flooded, and in some parishes, over 80% of the homes were lost.
Hundreds of people drowned.
I've seen a lot of dead bodies, and I saved a few people, you know, out the houses, and I could have drowned myself, you know.
Tens of thousands were stranded. Despite the evacuation orders, up to 120,000 residents remained in the city.
Many people didn't leave because they could not leave. They were either elderly or disabled. They didn't have cash in the bank, or they didn't have credit cards. And in some instances, no family or friends outside of the city.
They are getting sick out there. The water's getting pretty stagnant.
There was also concerns in a lot of people that they wanted them to evacuate because they wanted their land. New Orleans was a booming city, and there were developers who wanted some of their homes, and that they would be not allowed back.
I can be safe in here. I can watch my house. I don't want to leave.
If locals' faith in the system was frayed before Katrina, the failure of authorities in its aftermath tore it apart.
This is a devastating storm. This is a storm that's going to require immediate action now. I'm pleased to report the troops that have been called in that the convention center is secure.
By September 1st, 30,000 people had crammed into the damaged Louisiana Superdome. Another 25,000 in the convention center, both designated temporary shelters. Despite their official status, they had nowhere near the resources to cope with this scale of disaster. Conditions were diabolical.
There's 6 bodies upstairs on the 3rd floor, and then there's this guy right here that's dead. And they've been making promises to us that they were gonna move us, and people just really been getting frustrated at this point.
The media reported widespread looting, and the authorities appeared more interested in incarceration than relief.
We ain't got nothing. You know, we gotta steal from each other so we can survive and feed our children.
There were reports of isolated cases of violence among the abandoned population in the evacuation centers, as the evacuees were becoming increasingly desperate.
There were massive food and water shortages in the Superdome as well as in the convention center. And so you can imagine when there are tens of thousands of people in these conditions, how quickly you might think things would descend into chaos, and that was what the media really reported. Instead, it appears that people really began to self-organize to figure out how they could get the resources there that were necessary, especially for the most vulnerable people.
I thank God that everybody is sticking as neighbors and helping one another. If we didn't help one another in this city, we would be lost. Thank you.
Eventually, thousands of people sheltered in New Orleans were evacuated out of the city.
Keep your family members together.
Thousands of federal troops were sent in with ships.
I'm in National Guard. Do you need help?
And hundreds of helicopters. But it wasn't enough.
Right here. That way we get you prioritized for the next aircraft.
A plea was broadcast across local TV and radio for private boat owners to come to the rescue. They became known as the Cajun Navy.
Hurricanes, I really believe, bring out the best in people. Humans have a desire to stick together when the chips are down, and I think that a hurricane or an earthquake or something like that brings it out.
So we've studied this. There's actually a whole feeling of community cohesion, a kind of euphoric feeling that we can do this together.
Knowing your neighbor, being connected to your neighbors, and really helping one another to prepare for these extreme events may be one of the most important things that individuals can do in terms of increasing their own probability of survival in a disaster.
The Atlantic provides conditions for some tremendously large hurricanes.
The Atlantic basin often gets very, very wide diameter systems. They're really dangerous because the strong winds extend out for such a long distance.
Hurricane tracks from the last 150 years look like mad scribbles, drawn inexorably to the same location. Why does the southeast coast of the US act like such a magnet?
This ain't never, ever happened to us.
As with all weather patterns on Earth, if you follow them back to their ultimate source, you end up at the sun. As it beats down on the Sahara, the enormous desert that spans North Africa, heat radiates back off the landscape. As heated air rises several kilometers into the atmosphere, it turns and moves toward the Gulf of Guinea. This movement of air becomes the African easterly jet, a band of wind that moves across the Atlantic, heading straight to America. This jet gets kinks in it, carrying low-pressure systems known as tropical waves.
Tropical waves take on many forms, but they're sort of organizations of thunderstorms that travel across the tropics.
And this is how Katrina began. The tracks of most Atlantic hurricanes usually head back out to sea.
But it was very scary, very scary. Oh my God.
But the path of Superstorm Sandy, one of the most destructive and surprising hurricanes to hit the east coast of America, left many forecasters scratching their heads. Sandy formed late in the 2012 hurricane season, beginning fairly predictably in the Caribbean.
Las condiciones que tenemos aquí en la vivienda, ustedes pueden apreciar. No sé si podrá soportar el impacto del ciclón.
Sandy did form from tropical wave. It became a major hurricane as it crossed over Cuba and moved toward the Bahamas.
As a Category 3, Sandy tore across Cuba. Waves up to 9 meters smashed the Cuban coast, along with a 2-meter storm surge. More than 100,000 homes were damaged. And 11 people killed. And Sandy just kept going.
You know, after it had intensified and gone through Cuba, we expected it to go out to sea.
Due to a phenomenon known as the Coriolis effect, cyclones will spin in different directions depending on their location in relation to the equator. If the cyclone occurs in the northern hemisphere, they spin anti-clockwise, while the opposite occurs in the southern. This has a dramatic effect on a cyclone's path.
So in the southern hemisphere, they tend to curve out towards the southeast. In the northern hemisphere, they tend to curve out towards the northeast. And so in the case of the east coast of the US, it would be moving away from the coast.
But for some reason, Sandy bucked this trend.
It really got strange, but it made the left turn, which is very unusual for a hurricane in the Atlantic. Sandy kept growing in size. It started developing cold fronts and warm fronts. So it became a structure that was quite unfamiliar to most hurricane forecasters.
It then went through what we call extratropical transition. So in other words, it's moving into cooler waters. So it technically wasn't a hurricane anymore because it was a beast, basically.
As it passed over cooler waters, Sandy lost intensity, but grew in size, becoming the largest Atlantic hurricane in recorded history. At its widest, Sandy had a diameter of 1,400 kilometers. The beast's left curve into the most densely populated area of the US was the result of Sandy's collision with another weather system.
Turns out that there was a particularly strong system to the west of Sandy, cold air actually coming quite far south over the central and eastern United States, that played a role in Sandy's turn to the left.
The merging systems brought snow and ice to the mountains of West Virginia, with blizzards slamming into the region in a howling gale.
Crazy. You can't go nowhere. Trees in the road, the interstate shut down. Not much you can do.
Feet of snow in parts of the Appalachians. Just amazing.
So you had this juxtaposition of tropical hazards and wintertime hazards in such an event.
As the Appalachians froze, the northeast coast was smashed by huge storm surges, exacerbated by the full moon and high tide, 2 days before Halloween.
It hit us really, really bad.
So places around New York City and along the New Jersey coast were completely inundated. Big disruption, a lot of problems in a heavily populated area.
There was more than a 10-foot storm surge at the battery. It was higher than any structure they had to prevent it, and so once the water got over that, it had nothing to keep it from going into the subway and other things.
And so there were widespread power outages throughout lower Manhattan as well as in surrounding regions. That millions of people had their power knocked out. We also saw schools that were badly flooded. In Superstorm Sandy, people had to be evacuated because of flooding that was occurring there.
Hurricane Katrina had taught the US health system many lessons about preparedness. So even though damage and flooding were widespread, health services did not collapse.
Probably one of the biggest lessons we had from Hurricane Katrina was how the health system was not prepared. We realized that the healthcare system needed to take responsibility for itself and have its own emergency management approach. As a result, in Hurricane Sandy, the New York City area hospitals really did quite well in many regards. Though there were closures, they had been practicing and they had been preparing during that decade in between, and hospitals were up and running very quickly.
Finding boats in the middle of the road is not what anybody would hope for today.
The full moon and high tide enhanced the storm surge, along with climate change.
Though we knew with high tide it was going to be really bad, we just never thought it would be this bad.
Sea levels surrounding New York are around a foot higher than they were in 1950. This makes any storm surge more severe than it would have been a century ago.
The total cost was somewhere around $75 billion, and probably half of that is associated with the flooding of the subway system. And so the damage was tremendous.
Climate change is also warming the seas, which fuel hurricanes.
The best way to think of it, in my view, is that the storms mostly occur much as they did before. But it's in a warmer, moister environment. As a result, it can actually reach out and grab more moisture and bring it into that storm. It can invigorate the storm in that process. The strongest effects are in the tropics, so this relates to hurricanes in particular.
This had a dramatic effect on the deadliest Atlantic hurricane in the last 200 years. With a death toll over 11,000. It was the rainfall that turned Hurricane Mitch into an unrivaled human disaster.
Bueno, yo estoy para volverme loca, sinceramente. No. Mi vida es andar para arriba y para abajo porque mientras no encuentre el resto de mi hijo para enterrarlo tan siquiera.
Hurricane Mitch began in the Caribbean in late October 1998 and rapidly intensified, reaching Category 5 status in just 2 days. As it approached Honduras, winds had weakened considerably, but the storm became extremely slow-moving, producing a tremendous amount of rain in one region.
The hilly terrain was subject to all this incredible moisture moving in from the Atlantic and riding up on the hillside, creating devastating flash flooding. This happens in other parts of the world too, where you have such a tremendous amount of moisture coming inland, encountering mountains or hilly terrain where there's just so much water coming down at once that mudslides occur, and these can take out entire towns.
In Honduras, entire villages were washed away by mudslides.
It's all rain-induced, and it's easy to get 10 to 20 inches of rain on hillsides in a relatively short period. The soil underneath just can't withstand that, and eventually it just gives way and becomes liquid. It all slides down the hill. That's what killed most of the people.
Nos hemos dedicado a lo que es la búsqueda y recuperación de cadáveres. Entonces nuestra labor ahorita es ver lo que podemos recuperar de los cadáveres y
The storm's effects reached Nicaragua. One gigantic mudslide in Pozaltega killed 2,000 people. Rescue workers who tried to reach devastated villages were severely hampered by rising floodwaters. In Honduras, most of the land used for agriculture is on hillsides. With many years of slash-and-burn agriculture, farmers cut and torched forests to plant crops, clearing new areas again when soils became less fertile.
In cases where there has been a fire or deliberate logging and deforestation, you disturb the soil's ability to deal with the amount of water that's coming down directly as precipitation or runoff.
Once we start chopping down trees, in any environmental situation, we're going to cause damage, but also the stability of the land surface as well.
Dos tractores que agarraron río abajo. Y sí, en realidad son pérdidas millonarias. Trabajo de 30 años, que verlos perderse en 48 horas, sí duele, ¿va? Ahí lo único que lo sostiene a uno es la fe en Dios.
Mudslides demolished many of the country's crops. Bananas, beans, and sugarcane were hard hit, with losses totaling $480 million. Roads were cut off and bridges destroyed, leaving those desperately in need of assistance isolated. Much of the infrastructure was devastated. In both countries, a total of 2 million people were left homeless.
No les ha dado nada, ni comida, ni ayuda en materiales.
The months that followed became a life and death struggle for some of Latin America's poorest people, who had only recently started to recover from years of civil war. The impact was so devastating that the World Meteorological Organization permanently retired the name Mitch from its hurricane list. In the years preceding Mitch, tropical cyclones have become more severe, and the retiring of names has become more common. The 2005 hurricane season was so severe, it saw a record number of names retired. Dennis, Rita, Stan, Wilma, and Katrina. But for many New Orleans natives, the scars Katrina left will never fade.
You have the original trauma of the hurricane, which is extremely upsetting. You're seeing your house flooding. You might be seeing dead bodies floating by. This will go on for hours, if not a day or more, before you get help. Very traumatic experience.
As families are moved into temporary shelters in the aftermath, the stress is ongoing.
As a sociologist, I was particularly interested in studying how children were affected by the storm and its aftermath. Almost all of the children missed days, if not weeks, if not months of school. There were also impacts in terms of the shattering of friend and family networks. We also saw many longer-term effects for children in terms of who graduated. Had a lot to do with how many times they moved after this storm.
It's often said that natural disasters are the great equalizer, but the opposite is closer to the truth.
One of many insights that has come out of this work is that disasters don't dissolve pre-existing inequalities. What disasters do is they exacerbate social fault lines. When it comes to who has the resources, the capacity to actually prepare for, respond to, and recover from disaster, We know that that is profoundly influenced by social class, by race, and by other characteristics. Some of the populations that were displaced in Katrina included some of the most economically disenfranchised populations, and also were some of the areas of the city that were slowest to get the necessary recovery resources.
Almost 6 weeks after Katrina first made landfall, the last of the water was pumped out of New Orleans. But returning home is by no means an end to the trauma.
Even after a storm passes, the water stays in a building and continues to wreak havoc. And in many cases, homes had to be destroyed completely.
Just had these large expanses that were uninhabitable for a very long time. And even after the water drains away, you still have to deal with the cleanup, and the economic cost is enormous. The effects linger for years and even decades after such a devastating event.
The first reaction was I was glad I got out myself, glad I didn't stay, because I certainly wouldn't have made it.
Many important lessons have been learned from the mistakes of Hurricane Katrina. However, there's no guarantee it won't happen again, even in the same city.
And one of the unfortunate things is the Corps of Engineers has built back most of these levees to prepare for the next Category 3 storm, but they're not prepared for a Category 4 or Category 5 storm. And so this can easily happen again sometime in the future.
As destructive as tropical cyclones are, viewed as purely a meteorological phenomenon, they are an awe-inspiring and extremely important part of the natural balance of our world.
They are an amazing force of nature. Their symmetry, the way they move, the way they form is quite phenomenal. But they're also a mechanism which redistributes heat very effectively around the Earth. We need that to be able to perform that meteorological mechanism.
Continuing our scientific fascination with tropical cyclones is essential for better predicting where and when the next big one will hit.
They're extremely complicated to understand, and really understand. And to understand how they form, you need to really understand the entirety of atmospheric sciences, all the way from how water vapor behaves to complex dynamics in the atmosphere, and you have to put it all together.
It still never ceases to amaze me that this unbelievable machine, this scary creation, is just a natural result of the Earth's processes.
We know what we need to do in order to help populations to better prepare for disasters.
Come on, boy.
Right now, it's a question of, do we have the political will, and are we going to invest what it's actually going to take to help make communities and cities more resilient to natural hazards?
Of all natural disasters, floods are the most common and the most deadly.
When their bodies were found, many of them didn't even have body hair or clothing left.
They have the power to bury cities, decimate farmlands, and ruin economies.
These extreme rainfall events are known to produce some of the highest impact types of weather phenomena that we see around the world.
Floods are inevitable, but their catastrophic effects depend largely on human behavior.
When you have very urbanized environments, that actually can contribute more to the flood. We see these events all over the world where the weather event plus the vulnerability can truly lead to a major disaster.
My entire life forward just washed away.
How we build, where we live, how we power our lives.
These floods had a 1 in 1,000 year chance of occurring. But with climate change, it increases the odds.
And this much bigger flood wave then comes and hits a much denser population.
What can we learn from the big floods of our time? And how can we best prepare for an uncertain future? Around the world, humanity exists only moments from catastrophe. Disaster bubbles below the surface of the earth, strikes from the heavens, or engulfs us from the sea. But we are not merely at the mercy of our planet. In our pursuit of industry, global connectivity, and reach for the stars, lives have been lost. Disasters reveal the best and worst of mankind, as one tragedy compounds another. How do these disasters occur? And what lessons can equip us when catastrophe strikes again? Pakistan is a landscape of extremes. It sits on the edge of the world's warmest ocean, the Indian Ocean, and backs up against the icy peaks of the Himalayas.
It has this mountainous region that is very steep, but then after that, it's relatively flat. It has this mountainous region, very fertile lands.
From the glaciers to the sea runs the mighty Indus.
The Indus River is one of the biggest rivers in the world. It has a massive floodplain, and this is essentially the reason why that part of the world is so fertile and so productive in terms of agriculture.
The Indus Valley is one of the early cradles of civilization. Around 6,000 years ago, people here began farming the landscape and building urban centers. Now, more than 100 million people in Pakistan rely on the river for drinking water and irrigation. The Indus gets some of its waters from snow and glacial melt, but most from the enormous amount of water dumped each year by the Asian monsoon.
हम खुदा का शुक्र करते हैं कि बहुत अरसे के बाद कराची में बड़े इंतजार के बाद बड़ी गर्मी के बाद बारिश हो रही है.
Its people are no stranger to flooding. In fact, it's key to their survival.
Flood is essentially the inundation of water on a land that normally is not covered by water. This inundation can be massive. It can be really inundated for kilometers and kilometers and kilometers. It can be a minor inundation. These minor inundations are the frequent floods that civilization has depended on to sustain our ecosystems, or provide nutrients, or spread silt on floodplains. This is where the biggest, agricultural farms in the world have existed.
The Asian monsoon can vary dramatically in its intensity, as it's driven by heat.
Every summer, the monsoon starts about June, and it runs through August or September every year, and it brings most of the rainfall to the region. It's primarily forced by a difference in the land and sea temperature. In the summer, the land heats up much faster than the ocean, and this drives a lot of the oceanic moisture into the continent that is then focused by the Himalayas. And it creates copious amounts of rainfall throughout the country.
And this is the majority of the water that falls on the continent.
Every 3 years on average, Pakistan experiences a major flood. But 2010 was their most destructive in history.
The monsoon is a life-giving, source of water for a lot of South Asia. But that one was extraordinary in that there was an exceptionally long duration of heavy rain. There's also been a tendency in recent decades for the monsoon front to be a little bit further north, which is causing rain to occur in parts of the country that have more steep terrain.
Heavy monsoonal rain had already been falling through most of July, with floods creating havoc in Balochistan. But in the last week, a torrential downpour began to pound the northwest province of Khyber Pakhtunkhwa, a mountainous part of the country that normally remains arid and dry, even in monsoon season.
It was basically very weak precipitation that was formed by the uplift of moist air along the topography, which is very rare actually for this part of the world.
Some parts of the province reported almost 4 meters of rain in a week. The steep terrain concentrated the intense rain into pockets of the landscape, creating flash floods.
कभी इधर बैठाया कभी इधर बैठाया लेकर आया तो असु पीछे देखे नहीं एकदम पानी इतना इतना हो गया फिर जो है ना सर से ऊपर गया तो उन तक जो है ना देखे नहीं.
Basically, you get more rainfall into some of these river valleys that then collects and then floods the lowlands. And in this Pakistan case, actually, it flooded Peshawar, which is a river valley kind of in the lowlands, but the precipitation was concentrated over the complex terrain.
Think of a flood as a spectrum. On the very short-fused end of the spectrum, it rains, and even before the rain stops, within hours, you could have a very devastating flood moving through. That's a flash flood. In Pakistan, you had, in the initial stages with these big bursts of rain, you had flash flooding, especially in the steep areas where the water's going to flow faster. But then eventually that reached the big rivers, which swelled up, and it took days, for them to reach their peak as well. So they saw the whole spectrum.
Some tributaries of the Indus almost doubled their previous record flow rates.
Many rivers reach record levels. But even the smaller creeks, as you go up into the highlands, in some cases they were the first to burst their banks, cause flash floods, and that ended up downstream in the bigger rivers.
Locals describe the rivers as demons, consuming all in their path.
دغه تقریبا 1.5 کیلومتر 1 کیلومتر فاصله کې د خپل په بو کې ولاړم ما ته یو کس تا شنو چیرې ده سپنجه پنجه ښکاري چې ما کتو نو ما دې پنجه نو ما د پنجه نو پیژنده.
Although floodwaters subsided within days in the northern parts of Pakistan, more than 1,000 were killed in these early flash floods.
Floodwaters are one of the world's worst natural hazards in terms of loss of life and economic damage, and people quite often underestimate the power of water.
As soon as water starts to move, it can be highly destructive. Each cubic meter weighs a ton.
It can rip up boulders weighing tons. If it hits a building or a car or a person, then it just has an enormous force behind it.
For many Venezuelans, the power of water is something they will never forget. In 1999, a devastating debris flow hit the state of Vargas, a narrow strip of coastline to the north of the country.
The December 1999 floods in the north coast of Venezuela were exceptional because it was one of the deadliest recorded floods in history. In fact, I'm told in Vargas State, 10% of the population lost their lives.
In that event, tens of thousands were buried alive under torrents of mud and rocks, even as they slept.
Y resulta que hemos encontrado una gran cantidad de personas que están en estado crítico. Y lo peor que tienen es que hay una gran cantidad de cadáveres que están en proceso de descomposición.
There's a dreadful irony to the Vargas tragedy. Its history of catastrophic flooding is the reason so many people settled here in the first place.
If you're not familiar with the north coast of Venezuela, it's very steep mountains that come down to the Caribbean Sea. Historically, there have been many flash floods there that deposit a lot of sediment and debris, and they create these flat, fan-shaped areas called alluvial fans.
Alluvial fans are typically found where a canyon drains out from the base of mountains. They form when heavy rains lift the topsoil and rocks off steep slopes and carry them towards the ocean. These fans can be enormous. Entire cities have been built on alluvial fans.
Because these are flat, these are natural places for cities to build. So the population tends to be located on these alluvial fans. But these alluvial fans are still building.
One of these is the Carabayeda fan. The city of Carabayeda was founded several years after the last major flood event in 1951. By 1999, the population had swelled to more than 300,000.
In Vargas State, and in particular in the city of Carabaleta, we combine two things that we see so often in floods. There's the intense rain, and then there was the vulnerability. You had a major flood event, something that there's evidence has happened before, and you have now, what you didn't have centuries ago, a large population on the areas where the debris is being deposited.
December is not normally rainy in Venezuela. The wet season usually wraps up around October, but a cold front had interacted with a moist southwesterly wind in the Pacific Ocean, and heavy rains began to fall in the San Julian Basin, which feeds the Carabayeda fan.
There was a period of abnormally high rainfall so that the ground is wet, rivers are already running high, and then on the night of December 15th into 16th was the really intense rain.
Eyewitness accounts say debris flows began around 8 p.m. on the 15th, when a phenomenal amount of water cascaded down the mountainside, ripping apart the landscape and triggering thousands of shallow landslides.
There's a huge amount of water moving down a very steep slope. Once water's picked up a lot of debris and it's got boulders in it, then all sorts of structures will be vulnerable.
And all of this started coming down, and finally it hit this flat patch of land. That is where all the people were living, and it caused massive devastation.
The amount of water that came down the steep slopes in 3 days was almost double the yearly average rainfall. The United States Geological Society estimates around 1.8 million cubic meters were dumped on the city. The city was destroyed. Boulders the size of trucks were lifted off the mountainside and hurled into apartment buildings.
Bueno, esto fue algo inesperado, pero esta vez fue algo, como se dice, como si se hubiera abierto el Cerro Ávila.
Debris deposits were head high. No exact death toll was recorded because entire towns, including Cerro Grande, simply vanished. Only 1,000 bodies were recovered, but it's thought up to 30,000 people may have perished, either buried or swept out to sea.
Survival of those kinds of floods where you have a lot of debris in the water and it's high velocity water is very difficult. There was a study done in the United States in the state of Colorado where 144 people died in a flash flood in 1976, and the coroner had determined that none of them drowned. They all died from traumatic injuries. Many of them didn't even have body hair or clothing left when their bodies were found. That's the force of what happens in these steep mountain areas when you have all this debris coming down with the water.
This is an example of ferocity of a flash flood. A flood that is coming down a big river, a long river like the Indus or the Ganges or any of the long rivers. It's kind of predictable. With such steep mountains, the prediction time is nothing.
In the aftermath, 64,000 troops were deployed to Vargas, along with massive bulldozers to clear an access path to the towns. The major highways were buried, making evacuations difficult.
Ayuda de acuerdo a lo que nos ha solicitado, agua, alimento, y a ver si damos algún cola a alguna persona que quiera subir a Caracas.
For those survivors who stayed, there were little supplies for months. A notoriously volatile part of the world, looting was widespread amidst reports of rapes and other violence. Vigilantes patrolled the streets with sticks and baseball bats. The cost was put at close to $3.5 billion US. But despite the inherent risks of living on the Carabayeda Fan, the city began to rebuild once more.
Ahorita está todo destruido por todos lados y mientras que uno consigue, esto será dentro de 1 año, 2 años que arreglen esto, que uno se puede ir. Mientras tanto hay que seguir volviendo aquí porque ¿para dónde se va a ir uno? ¿Para dónde?
While severe floods have occurred on these alluvial fans since prehistoric times, the Vargas death toll may have been much lower had the steep terrain above not been deforested.
The rain that comes down, about 10% of that will get stuck onto the leaves of the tree. That's called interception. So basically you're having roughly 10% more rain coming down instantly onto the ground.
Forests help stabilize an area. So when you remove forests, the soil is much more prone when it's on a steep slope to just slide away with the flood.
So this whole process of the rain flowing to the river becomes much faster.
Deforestation has also stripped Pakistan bare in recent decades. When it became independent in 1947, around 1/3 of the country was covered in forest. Now, that figure is less than 2%. Some of the tree loss is due to poverty, with trees providing fuel and other resources. But most is attributed to the timber mafia, an illegal and ruthless logging organization which has operated under the protection of the Taliban. In the flash floods, logs from felled trees caused devastation of their own. Swept out of the valleys into raging rivers, they helped smash down every bridge in their path.
एक पुल भी नहीं बचा मालाकंड से लेके कलाम तक तो पहली हमारी कोशिश ये है कि लोग जो है कम से कम पैदल पार कर सके तो ये
More than 250 bridges collapsed in Khyber Pakhtunkhwa alone.
So you have damages and transportation routes not at just one bridge, but across the entire segment of the river.
Flash floods took out power stations, telecommunication towers, homes, crops, and other infrastructure, creating a rolling disaster.
The rolling disaster is essentially a disaster happening that is triggering off another disaster, that is triggering off another disaster.
न डर करना चाहिए बस अल्लाह सनाई करी गरीब साहबा गोरे जाऊं बा अल्लाह सनाई करी गरीब रब सनाई करी.
We have a major flood event. The services that sustain society, they are the first things to get disrupted. Transportation routes are impacted. People are unable often to communicate. All the stormwater services, all the sanitation services are not working. So it's like one problem after another.
By early August, floodwaters had begun to subside in the north and create devastation in the south. Punjab and Sindh were inundated as the Indus broke its banks in many places. The rains simply wouldn't stop. Deforestation helped silt up many waterways and dams, reducing their flow capacity. Ironically, so did levees, canals, and other structures built to tame the river.
The entire Indus Valley area is probably one of the most efficient irrigation networks in the world. But when you create canals, you don't really allow for the frequent floods to occur.
These minor floods should take the silt from the river and wash it out onto the floodplains. But as more canals and irrigation systems crisscross the landscape, less silt is escaping the river system.
So the amount of space you have between the bottom of the canal or the river and the land starts reducing. So the river levels start rising up over the course of time. Now when you have this big major flood coming along, this major flood impacts much more than what it would have had the river bottom been a little bit lower.
From degradation of the environment to failed engineering projects, a raft of human activities enhanced the 2010 floods. But of them all, the long-term burning of fossil fuels attracted the biggest portion of the blame. The intensity, northerly position, and persistence of the rainfall were all linked to anthropogenic climate change.
2010 was quite remarkable in many places around the world. The sea surface temperatures were very unusual throughout the tropics.
The overheated Atlantic waters triggered a vigorous hurricane season. And this helped set up a strange circulation pattern in the atmosphere. The Northern Hemisphere jet stream began to wander.
There are several components to the jet stream. The one we hear about the most, the polar jet, is a ribbon of air that flows west to east, and there are waves in the jet stream. And along those waves, that's where storm systems occur.
The westerly winds push these systems across the globe.
Sometimes those waves can get really amplified, so they're very north-south. When that happens, the bottom of the wave, what we call the trough, can become very slow-moving. So when you have a very amplified flow, you could get a storm stuck in one area, and you could get a dry spell in what we call the ridges stuck in another area.
And that's exactly what happened in 2010. This buckling of the jet stream carried the monsoon rains further north into Pakistan than normal. At the same time, Russia sweltered under a massive, stagnant high-pressure system.
They lasted for about a couple of months, enough to really cause major trouble in Russia, where it got extraordinarily hot and dry. Wildfires broke out. Things got quite out of control, in fact. And then, not that far away, in fact, there were substantial floods over Pakistan.
We found anomalous circulation patterns that brought warm, moist air from both the Arabian Sea and the Bay of Bengal all the way up into the region near northwest India and Pakistan. that then rose up the terrain, and it eventually caused the floods that occurred throughout the month.
Although the majority of deaths in Pakistan were due to the flash flooding, it was the persistence of the rain that displaced so many people.
The Pakistan 2010 flood actually was more of a slow-rise flood.
What happens in many of the big flood and drought events that we see around the world. But again, there's some studies showing there's a somewhat greater tendency for that to occur in recent decades.
There is evidence that over the last 60 years, the jet stream is the waviest it's been for centuries, favoring more of these systems that become stuck. A leading theory is that a warming Arctic is a major contributor.
So one of the things that helps drive the jet stream is the Arctic and the Antarctic are these real cold reservoirs. And what causes the jet stream is the thermal difference between the north and the south.
The temperature difference between these icy regions and the tropics drives the winds that form the jet streams. The Arctic is warming faster than anywhere on Earth. And in summer, much of the Arctic is now ice-free. It's lowering the temperature difference between the tropics and the poles.
So rather than this real strong west-east jet stream pattern in the northern hemisphere, the fact that the Arctic isn't as dramatically cold as it used to be is allowing more of that wavy pattern. That's as the theory goes. There's still a lot of discussion and debate about it, but there's more and more scientists studying that idea.
Like a lazy river, the jet stream is wandering all over the place. And this favors all sorts of unusual and persistent weather systems. From severe drought to unseasonal blizzards, to torrential rains that just won't go away. But there's another way global warming intensifies floods. Louisiana, on the southeast of the US, sits at the edge of the warm waters of the Gulf of Mexico. This is a state used to a good drenching.
Southern Louisiana is a place that gets heavy rain. There's no doubt about it.
But the rains that fell in 2016 were off the charts, dumping as much as 7 centimeters per hour in some parts. Baton Rouge bore the brunt of it.
My entire life forward just washed away.
Hurts you to your heart to see them, that happened to them, but that's what happened.
It was a weak tropical depression that didn't have a strong circulation attached to it, but it had tremendous amounts of rainfall. There were some measurements along the coast, along the Gulf Coast, and they recorded the largest amount of moisture in the atmosphere that had ever been recorded in that area. This is associated with quite warm conditions in the Gulf, and the moisture was coming out of the Gulf and just dumped a tremendous amount of water on the ground in that region.
At the same time, in the center of the US, a shortwave trough was forming. This is an atmospheric disturbance that causes air to rise ahead of it. The trough drifted towards the Gulf of Mexico. Eventually, the two systems met and produced a double lift effect. The warm, moist air rose rapidly, then cooled before the rains came down.
This is kind of what you associate with a very violent or vigorous thunderstorm that you see with strong updrafts, very high precipitation rates. Sometimes you have hail.
Nearly 26 trillion liters of water were dumped on Louisiana in a week. 3 times more than during Hurricane Katrina. It was unprecedented in anyone's living memory.
We actually lost everything. Katrina came here, and 10 years later lost everything again.
So I think when they started getting these tremendous amounts of rains, day after day after day, The disaster was already unfolding around them before people and officials started realizing, wow, this is actually a lot worse than it first appeared it might be.
But it wasn't just a once-in-a-lifetime flood.
In terms of the past records, they were regarded at the time as 1 in a 1,000-year floods in some locations. But with climate change, these are not unexpected, but to many people, they are.
The Amite River rose almost 1.5 meters above its previous record level.
Here in the United States, many cities designed their systems with 50 or 100 years of flood record. That's not enough to tell us what the big ones are. And when you have very urbanized environments, that actually can contribute more to the flood as well, because pavement and development tend to inhibit the ability of water to soak into the ground. So cities are known to actually flood with less rain than rural areas.
In the Louisiana floods, 13 people lost their lives, most of them in cars.
So in societies where cars are more prevalent, people are used to driving their cars and they feel quite safe in their cars. But really a car's just like a bubble of air, like a balloon.
Ironically, most car deaths happen in the larger, heavier vehicles, as drivers presume them to be safe.
So we ran a series of tests on a range of different cars. So a large four-wheel drive in 60 or 70 centimetres of water, the rear wheels will start floating. We were quite amazed at how little water it did take for those vehicles to become unstable.
That guy just went right through there, John.
Once the water rises above the floor of the car, it will interact with a bubble of air in the cabin. For compact cars, this is not even knee height.
Smaller cars will start floating in very shallow water depths of the order of 30 or 40 centimetres. Once you're floating, you go where the water goes, and usually it's water going over a road embankment or over the top of a bridge that lifts the car off and then pushes it off the embankment or off the bridge into deeper water.
Roadways are completely flooded. You can't see any of the signage, basically feeling your way through high water.
In Louisiana, emergency services were overwhelmed with the volume of people needing rescue. So, the Cajun Navy stepped in.
So the Cajun Navy is this group, predominantly of boat owners, who are from the U.S. Gulf Coast, who, after a number of major disasters, they have actually come together. They've taken their boats, they've mobilized, and they've gone out and they've actually rescued people during these flooding disasters.
We had a boat, so we're trying to do whatever we can in our time of crisis and disasters.
The Cajun Navy formed during Hurricane Katrina and reactivated in the Louisiana floods and Hurricane Harvey, rescuing thousands of people.
They actually used social media and they used other data sources to identify where stranded populations are located and so forth. And so the Cajun Navy really seems to be all about people coming together to help people.
Before floodwaters had even subsided, media reports began to ask whether there was a link between the extreme flooding and climate change. To address the question, a rapid attribution study was launched using the best available observational data and climate simulations. They found that rising temperatures had almost doubled the likelihood of a disaster like the Louisiana floods.
Most of the heat is ending up in the oceans, and this has consequences. It means the air above the oceans is warmer, and the air is moister. And this then affects all storms.
It affects storms because heat energy allows water molecules to break free of the surface tension and become water vapor, or evaporate. The warmer it gets, the more water vapor can be transported.
Let's say you're not putting any more water down on the surface, but you're just redistributing how it occurs. There could be areas that have long dry spells. And then where it does rain, because the oceans are warmer, they're pumping a little bit more moisture into the atmosphere. It can rain much more intensely than it had before.
The scientific community has established that there is typically a 7% increase in the extreme rainfall that can occur with each degree rise in warming. This has resulted in extreme rainfalls across the world increasing. Coupled to this, the fact that we have more people in the world. These populations essentially are congregating more and more towards the cities. The cities lie near the rivers where the water lies. You have more people, more infrastructure assets being exposed to any flood damage, and these floods are more intense because you're having this much more rainfall coming down.
Heated waters also provide the driving force for cyclones, which can help create severe flooding events, especially when they come in the middle of a wet season. Mozambique is an African nation on the southeast coast. It's a downstream country. 9 of Southeast Africa's major rivers, including the Zambezi, cross through Mozambique on their way to the ocean. It's one of the poorest countries in the world, and with a lack of irrigation infrastructure, most people live right on the waterways.
Most settlements, wherever you are in the world, are nearby rivers and streams. A lot of farming also occurs on floodplains because of the soil that comes down the catchment in these floods is very rich and fertile for growing crops. So a lot of settlements are on river floodplains because of that reason as well.
Whatever happens upstream, Mozambique suffers the consequences.
Mozambique in the late fall of 1999 into January of 2000 had quite a bit of rain, and many of the rivers were already at or above flood stage. In fact, by the end of January, there had already been 700 deaths in Mozambique. Then on February 22nd, tropical cyclone Helene hit, as if, they didn't need something worse, and that was just something that the country couldn't deal with.
Helene just happened to be the longest-lived cyclone on record. An extremely slow-moving system that traveled more than 11,000 kilometers. It turned an already catastrophic flood into Mozambique's worst natural disaster in a century.
The channels of the rivers were already full, the soil was already moist, the emergency services had already been stretched. On top of that, this is a very, what we call a hydrologically sensitive area. Any additional rain isn't going into the ground.
Parts of the country that had never been flooded were now underwater. By the beginning of March, 1 million people were homeless. Mozambique, with only one functioning helicopter, used by the president, was severely underprepared.
There are thousands of people out there who really need to be rescued, and the helicopters you see behind here are totally overwhelmed.
6 South African Defense Force helicopters saved thousands of stranded people.
The situation is really bad. It's perhaps the worst thing I've seen in my entire life.
As neighboring countries mobilized their forces to deliver more helicopters, boats, aid, and finances, Mozambique's own history of conflict came back to haunt its citizens. Once the most landmine-riddled country in the world, the government had made exhaustive efforts to clear the explosives.
that now we're going to have a problem. Where they are the mines that have been washed out, nobody knows.
Plastic-covered mines were carried away in the floods, creating new minefields where none had previously existed.
As you see, this is a PMN that is with explosives and with the metal contamination, you know.
Tracker dogs and survey teams were sent on a dangerous mission to locate the mines. As problems mounted, a health emergency deepened.
You have inundation of farms, animals dying, livestock essentially becoming a part of that same water. That again breeds diseases. You typically have gastroenteritis, you have waterborne diseases, you even have cases of malaria.
Water becomes a breeding ground for mosquitoes and malaria.
The problem when you have large amounts of displaced people, they tend to be crowded into certain areas where maybe they're not getting the proper nutrition, and that just can make the whole situation of spreading disease and illness greater.
So it's like one problem after another that keeps on happening, keeps on accumulating. Because of this, you have a complete collapse of the health situation.
By mid-August, Pakistan was also beginning to face a healthcare emergency. As the rains continued, a fifth of Pakistan was now underwater, an area roughly the size of Switzerland, Belgium, and Austria combined.
So in Pakistan, being a densely populated country, and a fifth of their land is submerged during this flood, the fact that 20 million people were displaced is not a surprise. That's not something the country's going to recover from very quickly.
Of the millions affected, many were in desperate need of food, medical care, and most of all, clean water. Many became incredibly angry at what they perceived to be a lack of response by the government.
Many of the bridges were broken, a lot of the dams were flooded. A lot of the lowland regions where people live were completely flooded. So getting the aid to those populations required air support as opposed to ground level support, which brings a lot of challenges.
Although 30,000 troops were sent in, aid was patchy and inadequate. Soon, the first cases of cholera began to appear. Cholera is often a fatal disease caused by eating or drinking bacterially contaminated water.
मसला बच्चों और बड़ों में ये है कि उनके पेट खराब हैं, डायरिया का मर्ज है और बच्चों, बड़ों, औरतों में बिलखसूस जो है ना खारिश बहुत ज़्यादा है। खारिश लगी हुई है, जिस्म दानों से भरे हुए, पानी में रहने की वजह से तमाम लोगों के जिस्मों में दर्द है, बुखार है, खांसी है।
Crowding exacerbates the problem as the bacteria is spread.
But even more than that, when you have a flood sweep through, especially in an urban area, you have things like sewer lines that break and other toxic material that gets into the water, and so water becomes unsafe and diseases can spread that way too. So you have both the insect-borne diseases and the stuff associated with sanitation being disrupted.
In a survey of flood survivors, it was found that the vast majority of the villages were getting their drinking water mainly from flood and rainwaters, or rivers and springs.
So the key word here is vulnerability. So you could have a very major weather event like a flood or a tornado that either impacts a low population area where no one lives, or impacts a population that's very accustomed to these and prepared for it, and so its impacts will be small. Then you could have a severe or even a moderate weather event like a flood that impacts a population that has substandard housing that can collapse very quickly, that have no resources to fall back on if their farms are destroyed, or that are elderly or disabled and can't evacuate very quickly. Pakistan is, of course, an example of a country that has some vulnerable populations, and with the heavy rain they got, it was truly catastrophic.
At the end of the 2010 floods, the official Pakistan death toll stood at close to 2,000 people. A figure dramatically lower than the millions left facing a devastating future.
After the rains ended, there was still a humanitarian disaster where there were diseases and there were, food issues and all kinds of problems that came with this massive flooding event.
In terms of the size of the population affected, it was 6 times greater than the 2010 quake in Haiti, and 9 times greater than the Boxing Day tsunami of 2004. Floods destroyed many cotton crops. Electricity shortages paralyzed the textile industry. Food prices surged. Families lost their loved ones, livestock, homes, lands, dowries, and goods. For some people, life would never be the same again. The devastation caused by extreme flooding shows how fragile we all are. The predicted increase in the frequency and severity of severe weather events, coupled with an exploding population, may test the world's capacity to cope. In the face of both in combination, is there anything that can be done to better prepare ourselves?
The first thing is to stop burning fossil fuels in particular and transition to a very low carbon economy.
The other option is go back to engineering. Now, engineering options are expensive. They cause a lot of disruption. But given the options that exist with us, I don't see what else can be done.
The Western countries that have put most of the carbon dioxide into the atmosphere have a moral and ethical responsibility to help developing countries to develop the technology and to build that resilience.
Even in disadvantaged countries like Pakistan, huge change is possible, where there is political will. Since the flooding in Khyber Pakhtunkhwa, its government launched the Billion Tree Tsunami Project in 2014 as a challenge to global warming. It has already overshot its target of 1 billion new trees by restoring and planting 350,000 hectares of forest. These trees are also helping to secure river embankments, as well as heavily degraded slopes. It is the largest ever eco-project in the country, and such a source of national pride that many other provinces are considering the same. Before 2014, it was just an idea.
So I think there will be major changes in the future. The question is how quickly we're going to get there.